All right, go ahead for me, Ms. Lewis. Sorry about that.
All right. All right, so let's continue. So the cumulative frequency curve is one of those graphs that normally come on the exam paper, and it normally comes on paper 2. So normally a question will look like this. I said the table below show the distribution of the masses of 100 packs, right? And they will give you a table with the cumulative frequency partially completed. And the first thing that they ask you to do is to copy and complete the table to show the cumulative frequency for the distribution. Now, the instruction said copy and complete. It did not ask you to continue the completion of the table in the previous table, right? So what you're going to do is to redraw the table and complete the cumulative frequency section of it. Now, to find the cumulative frequency, as you see here, all they did is that they add. So for the mass of 1 to 10, it's 12 packages. So the cumulative frequency for that is also 12. For 11 to 20, it's 28. Now, what they do to find the cumulative frequency for that section is to add the 28 to the 12. And that's how we get the 40. Now, how would we get the 21 to 30?
Add the 30 to the 40.
Add the 30 to the 40, which will give us what? What would we get when we add 30 to 40?
70.
70, right? So that's what you do until you reach the bottom. Now, at the bottom of the cumulative frequency section, how much do you think you're going to have at the bottom from 41 to 50?
Miss.
100.
100, because it said a maximum. Yes, Russell?
Miss, I also go over that, please.
All right, let's go again. So this is a table which they're asking us to complete a cumulative frequency graph for. The first question said, copy and complete the table to show the cumulative frequency of the distribution. Now, you're not going to complete the cumulative frequency in the table that they have given to you. You're basically going to create a new table with the same information that is ahead, right? And complete the cumulative frequency. Now, for the cumulative frequency, all you're doing is just adding the number of packages going down. So for mass 1 kilogram to 10 kilogram, it's 10 packages, 12 packages, sorry, right? Now for 11 to 20, at the cumulative frequency, we see where we have 40. Now, how do we get that 40? All we are doing is adding the 28 package to the 12 package to get 40. So for 21 to 30, as your fellow classmate said, we're adding the 30 to the 40 to get 70. Right? Get that?
Okay, my question is that why the 12 you added to the 28, is it the packages or the cumulative frequency?
The packages, we're adding the packages to find the cumulative frequency.
Okay.
Right, so if you look at masses 1 to 10, go again?
Wouldn't you add 30 to the 28?
No, all right, follow. So for the masses, 1 kg to 10 kg, we have 12 packages, right?
Right.
So that's the cumulative frequency. For the 11 to 20, we have 28. For us to find the cumulative frequency for that, we have to add the 28 to the previous 12 that we had on the cumulative frequency table.
Right.
Right. So 12 plus 28 give us what?
The 40.
40. For us to find out the cumulative frequency for the 21 to 30, we're going to add the 30 packages that is in that section to the 40.
So that's 70.
Right? Then for 31 to 40, what do we add to the 70?
The 22,
22, which give us what?
92,
92. And for the 41 to 50, we get what?
100. But adding 92 to 8.
Right, 92 to 8 give us 100.
to the
So you see
8. So
at the end,
Miss Lewis,
yes, sir?
can I use the marker? I think it'd be easier to just use the marker and this the marking feature and just write in the values.
Where do-
Yeah, look at the bottom. There's a pen. Just click on it, double click on it,
Mhm.
and see if the cursor becomes a marker. Right. I think what happened a while ago is that they were right. So just you cannot show them that it's the 12 and the 28. Just put the 12 on the cumulative frequency and the 28. Just draw an arrow to indicate that that's what they're. The 12 on the 12 on the cumulative frequency, right? Draw the line, right? So they're adding the 12 and the 28, right? Mhm. Cool.
Right, so at the end of the cumulative frequency, we're supposed to have 100 because in the question, it said that there are 100 masses of packages, right? No, that's all they asked us to do for A. Now for B, it said using a scale of 2 centimeters to represent 10 kilograms on the x-axis and 1 centimeter to represent 10 packages on the y-axis, draw the cumulative frequency curve for the data. Now, first thing first, when you're drawing a cumulative frequency graph, we cannot use the midpoint for these masses over here, right? Because you'll be wondering, how can I put a mass from 1 to 10 on a graph, right? We cannot add, say, 1 and 10, and then that would give us 11, and then find half of 11. We cannot do that. Now, for us to plot the cumulative frequency on the curve, we need to find the upper boundary. And normally cumulative frequency curve work with upper boundary. So you can add this section of the table to your table that you have previously drawn, and you can label it upper boundary. Now to find the upper boundary, to create the cumulative frequency curve, all you're doing is adding the upper limit of the first mass and the lower limit of the second mass and dividing it by 2. What's the upper limit of the first mass?
21.
The first mass, the first set of mass, 10, right? And what's the lower limit of the second mass? 11. Now what's 10 plus 11?
21.
21 divided by 2.
10.5.
10.5. That's how you find the upper boundary. So the upper boundary for the mass of 1 to 10 is 10.5. You can add this to your table as I stated before. Now, what would be the upper boundary for the second mass?
20.
20,
20 to the 21.
which will give us what?
41. So that's basically 20.
20.5.
20.5. And for the third one?
30 to 31.
So 30 plus 31 divided by 2.
30.5.
30.5. Now you can see a pattern here that all we're doing is adding. What are we doing? What's the pattern that you're seeing?
Add 10.5.
10.5?
10.
Let's add 10.
Just add 10.
We're just adding 10.
Yeah.
Right, as you can see there, we're adding 10, but that's not the pattern that I'm looking for. So the pattern that I'm looking for is that you're just adding 0.5 to the upper limits. You see that? So you're adding 0.5 to the 10, 0.5 to the 20,
Yes.
0.5 to the 30, and 0.5 to what?
Miss Louise.
Yes?
It's the last when time I finish with the table.
All right. It's what me last you know.
When you finish with the table.
When we finish with the table? All right. What we're doing at this point is we want to create the cumulative frequency curve for the B section of the question, right? They ask us to create the curve. So they ask us to draw the curve. But the thing is, we cannot use the mass that is on the left-hand side of the table to draw the curve, right? So we cannot use 1 to 10 because we are not doing a bar graph. And we cannot find the midpoint either. So we cannot add 1 and 10, get 11 and divide it by 5. So for us to find what we're going to be putting on the x-axis and the y-axis and the x-axis, yes, we need to find the upper boundary for the masses here. So what we're currently doing now is finding the upper boundary, right? So for us to find the upper boundary of each of the mass, what we do is that we add the upper limit, which is the 10, plus the lower limit of the second mass, which is 11, and divide it by 2. So 10 plus 11 give us 21, and when we divide it by 2, what do we get?
10.5.
10.5. For the next one, it is the upper limit, which is 20, plus 21 divided by 2, which give us what?
20.5.
20.5. The next one is what?
30
Mm-hmm.
plus 31.
Mm-hmm.
Yeah, 40.5.
Divided by 2, give us what?
40.5.
40.5. Now for this one, what do you think we'll be adding? 50 plus what?
51.
50 plus 51. How do we get 51?
And we'll say the other. Because I want the over to a left would be a lower number.
Limit. Right. So 50 plus 51 divided by 2 give us what?
50.5.
50.5. Now, this is your section using the graph paper that Mr. Stephen had told you about earlier. I want you to rule up your graph. He said using a scale of 2 centimeters to represent 10 kilograms. What does that mean? How do you represent this on your graph paper?
2 centimeters. When time you count off the 2, they say you go put the number, the 10 kilometer.
Right. So on your graph, here would be what? 1, and here would be 2. Where would I put the 10 kilometer now?
At 2.
At the 2. So instead of having 2, I would have what?
1, 10.
10 kilometers. So you have 90 seconds to draw up your graph.
So do you have a graph to display? Like
No, sir.
Well, can I go to this? There's a section that's called whiteboard. You can probably and if you can change the color of your ink to a little bit darker. All right. And while you guys are drawing the graph, let me just also mention about this table here. So essentially, you know, it's like Amazon, and what they're saying is that if you look at the first row, 12 packages of a weight between 1 and 10. 28 of the package of a weight between what? 11 and 20. That's all it's saying. That's what the table represents, you know? It's a series of Amazon or whatever packages that you're purchasing from overseas, you know? And let me just remind you that on the left, if you look at the mass column, the 1, the 11, the 21, the 31, and 41, those are what we call the lower limit. All right. And Miss Lewis would have also mentioned about the upper limit. The 10, the 20, 30, 40, and 50 would have been the upper limit. All right. Now, let me just also mention that you see the 1 and the 11 on the mass column. Are you guys with me? The 1
Yes,
and the 11. If you're to subtract 1 from 11, what do you get?
10.
10. If you're to subtract 11 from 21, what do you get? The same 10. As a matter of fact, 10 is what? Constant. Now, that 10 is what we call the class size. Okay? And we get the class size by subtracting successive class intervals. So the 1 from the 10, sorry, the 1 from the 11 is 10, the 11 from the 21 is 10, the 21 from the 31 is also 10. All right. I guess you could probably subtract the 10 from the 20 on the right hand also. All right. And Ms. Lewis would have also mentioned that if you add 0.5 to the 10 on the mass column, if you add 0.5 to the 20, 0.5 to the 30, 0.5 to the 40, 0.5 to the 50, we get what we call the upper boundary or the upper class boundary. All right. Now, let me just also mention on the left column, if you're to subtract 0.5, so on the right hand, you add 0.5 to get the upper class boundary. But on the left column, if you subtract 0.5 from the 1, we also get what we call the lower class boundary. All right. So you have 0.5 where the 1 is, that's the lower boundary. And then what will be the lower boundary for the 1 beside 11? You're going to subtract 0.5 from 11. What is 0.5 from 11? It will be 10.5. 10.5. And to get the lower boundary for 21, it does 0.5 from 21, which is 20.5, etc., etc. So we have the lower class boundary on the left-hand side, where we subtract 0.5 from all those values. And what we call the upper class boundary, we add 0.5. But for this question, to plot the graph, we will use only the upper boundary. So that's why we're just working out that alone. So the upper boundary and the cumulative frequency. So make a note. Whenever we're plotting a cumulative frequency curve, we use the upper boundary and the cumulative frequency. All right, so make a note about that. Let me also mention one more thing. What does mode mean again?
Sorry, amount of time and number repeats itself.
Right, the popular one, not sure. Right, no, you see, because this data set is grouped, the question would ask you, so let me just say something there. Is it the 1 to 10, the 11 to 20 row? All those are called classes or class intervals. So the question they would ask you, what is the modal, not the mode, you know, what would be the modal class? So if I were to ask this question, what is the modal class for this data set? What would it be?
41 to 50.
And unfortunately, no, you know.
Sir, 5.
All right.
10.
No, hold on. When your answer should be either 1 to 10, 11 to 20, 21 to 30. Those are the modal classes, you know. So your answer should be 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50.
All of them.
No, man, what? No, it's
21 to 30, sir.
21 to 30.
right, the one with the 30, right? Because remember I said no. 21 to 30. How much package do we have? 21 to 30 kilogram. 30. So the 30 is the highest value, not true? So in other words, enough of the package, it's enough of the package that you want to ship down, have the weight between 21 and what? 30. So the answer is, so the modal class would have been 21 to 30 kilogram, because enough of something they want to ship down have that the weight there. 30 of them. You follow?
Yes.
No.
All right.
Yes, sir.
Hold on, who said no?
Me.
All right, EMS. Mode, right? Mode means the data set that occurs most frequently. Now, because this data set is grouped, all right, it gives you a range of information. So for example, 12 of the box them have a weight between 1 and 10. 28 of the box them have a weight between 11 and 2. In other words, there's no specific weight for each box. They just said, well, just give a rate.
They use the number of package to determine the mode.
Yes.
Okay.
Remember, you see the number of packages, it is also the frequency, you know. So the number of packages is actually the frequency. All right.
All right.
Yeah,
But you
man.
did
So,
before in time you the or you upper boundary and something.
come again.
A point where this almost jot down, we never get all right.
So what I'm saying, this question wants us to construct a cumulative frequency curve. Now, to construct a cumulative frequency curve, we use two things to plot it. That's why Ms. Lewis was saying you can't use the 1 to 10, the 11 to 20. You have to get one value. And the value that we have to use is what? The upper boundary and the cumulative frequency. So that's why she drew another column and work out the what? The upper boundary. In other words, you can't use the 1 and the 10 and the 12.
Sir, may I ask if you repeat the point where this almost jot down?
You not tell man?
No.
Use the upper boundary and the cumulative frequency to plot the cumulative frequency curve. That's the point. Whenever you plot the cumulative frequency curve, a two something you're going to use. Upper boundary and the what? The cumulative frequency. All right. Another point. Do you notice that at the bottom there, we get back the 100, don't you?
Hey, tapping eyes on my head.
All right. So at the bottom here, so we get back the 100, right? Cumulative just means an accumulation of numbers. That's what it means. So, you know, we keep on adding. All right. So those are some additional points about this thing here. And another point too. We use the cumulative frequency curve mainly to find the median. Get that? So make an important note. What do we use the curve for though? Find the median from group data. But a while ago when I was doing the multiple choice, we noticed those data was just like raw data. So you can just mark off the middle number, not true? But because this data here is grouped, to find the mean, the median, we have to construct a cumulative frequency curve. Follow?
Yes, sir.
Yeah, man. All right. Miss Lewis, well, you guys do up the graph paper? All right. Miss Lewis, take it away. Miss Lewis, take it away here.
All right, so everybody have the graph, they have the axis where 2 centimeters represent 10 kilogram on the X and 1 centimeter represent 10 packages on the Y.
Yes, miss.
All right. Now, using the cumulative frequency and the upper boundary as was stated before, I want you to go ahead and plot your point. So what are the two first points that they're going to plot on the graph? What is the first point that they're going to plot on the graph?
Mr. 12 and 10.5.
12 and 10.5.
12 and 10.5. So do we go 12 on the x-axis or 12 on the y-axis?
Y-axis.
12 on the Y.
And 10.5 on where?
On
X.
the X.
And the x. So go ahead and plot your point. Quickly plot all of the points, all 5 points.
So you want to use the whiteboard feature?
I don't have a whiteboard feature, sir. Do I?
Yeah, man. Look at the bottom of your screen. You see whiteboard. Click on it.
The Zoom screen,
Yeah, on the Zoom screen.
the options are at the top, but I don't see any whiteboard.
Oh, I wonder if we can do it.
Go ahead, sir.
Okay, if I open a whiteboard, it's gonna stop share screen. Okay. Are you guys seeing my?
Yes, sir.
All right, so. Oh boy. So I'll draw the graph for Miss Lewis. So this is CF. Miss Lewis, this would have been mass, not true?
Yes, sir.
Mass. And slash kg.
Right.
Where you go again? What is scale go again? Where you go again?
2 centimeter to 10 kilogram
On the X?
on the x-axis.
All right, so the first CF is what, 12?
Yes, sir.
And the
12.
last one is what, 100?
100.
Whoa. No, sorry. No. On the
10.5.
10.5 would have been the. What's the last upper boundary?
50.5.
50. Okay. So. Oh boy, I don't like this.
I can download and graph paper for Googling.
Yeah. Let me let me do something. Let me do that. Geogebra.
According to Geogebra.org, free online apps bundle from Geogebra, get graphing, geometry, algebra, 3D, statistics, probability, all in one tool.
All right, you guys hold on,
Yes,
hold
sir.
on, hold on. You guys see my little graph?
Yes, sir.
Hold on. What I like about CXC sometimes is that them they actually draw this graph for you. Sometimes. All right. So this is the Y. This is C, the cumulative frequency. And down here, so now, I hope I have enough space, is your X. And this is in kilogram, kg. Always label your graph here. So it says 2 centimeters. So this, you see from right is to right here, so it's 1 centimeter. So this is 2 centimeter. So what they're saying, 2 centimeter represents 10 units. All right. And then therefore this will be what? 20. So you go?
Yes, sir.
30. 60. All right. So let me ask a question. If from
So
here,
your time.
if from here to here, so it's 10, you see? What is the value of one small line?
0.5.
No, sir.
5.
1. 5.
All right. Let me ask a question. What would right here so be? No, 5.
Yes, sir.
That means
Yes,
a one
sir.
one line of 1.
Yep.
Agree?
Yes, sir.
Yeah. All right. Mr. Lewis, all scale upon the Y. Go again.
1 centimeter to 10.
Oh, 1 to 10. Wow. So 1 centimeter is what? 10. And it goes up by 100, not true?
Yes, sir.
I think my graph are rolling. So this is 20,
You will well, sir.
30. Yeah, for it actually full whole. A 100. Let me see who's smart. On the y-axis, what is the value of one small line?
2.
All right. Because how you reach the 10, you have to count by 2. Because of 5 small lines, so 2, 4, 6, 8, 10. Or what you can do, you know, what you do, you divide the unit by the number of lines. So 10 divided by 5 is 2. You follow? Look at the one on the x-axis. The unit is 10, right? And how much lines between the 0 and the 10? 10. So 10 divided by 10 is what? 1. So if you're having problems determining the value, because you need to know, you know, because the numbers are not nice. All right. All right. Take it away, Ms. Lewis.
All right, so the first point that we're going to be plotting is 10.5 to 12, right? So the first thing that we need to do is to identify where we're going to find 10.5. Now, as Sir Stephen has said earlier, that between 10 and 20, that middle line will be what?
10.5.
The middle line between 10 and 20 will be 10.5. Look at it again.
15.
15. So where would we find 10.5 now? If one of the line represent 1, as you said earlier, where would we find 10.5?
You know, an Arabic box.
Right, so we'll find it at 10, between 10 and one of the tinier box, right?
Between 10 and 11.
Right.
Yes.
And then we're going to where? Up to where?
12.
12.
But where is 12?
Where do we find 12?
The first line after the
First
10.
line after 10.
Right.
All right, good.
So it's kind of difficult on my thing. So remember that. Let me try to zoom in. All right. So let us magnify this section here. So what happened is that. So that's 10. And then you have 1, 2, 3, 4, 5. We have 15 there, not true? So what am I saying? It's a 10.5. You have skill now, you know. You have 10.5 going to be in between the 10 and 11. So you have a skill. And let me tell you something. I would have marked CXC before, many years ago. My first time marking, and actually got a stats question to mark. And I had to look for the in-between, believe it or not, they look for it. So you have to be skilled. All right. So you have to go drink up a carrot juice. All right. Yeah, man.
Sharp pencil.
Yeah, man. And get a sharp pencil because guess what? Yeah, some pencils were thick, you know. With the pencil thick, when you draw, like it fill up the gap. So 10.5 is in between. All right. So I can't do it on my graph because, you know. All right. So let me try. So I'm thinking
Just put a little that, sir.
yeah, it's gonna be right there. All right. And then whenever you put a dot, put a circle around it. That's how I like to do it. That's our first point. Oh, by the way, let me just mention that is it right here, so? I saw it called Ogive, Miss Lewis, I saw it go?
The curve is called an Ogive.
Ogive. So you mean to all them years I'll be a foolish man to put them.
The curve itself, sir. The shape of the curve is called an Ogive curve.
All right.
All right, and for the next point, it will be somewhere similar. So 20.5 will be found somewhere similar. And where on the x-axis do we go for that one? Where on the y-axis, sorry?
40.
Up to 40. Right, then we have 30.5, and we go up to where on the y-axis?
70.
70. And for 40.5, how far up do we go?
92.
All right, 92. And for the 50.5?
100.
Up to 100. Down, sir. Down.
Hold on. After
92.
So hold on it. No, right, that's all. Oh, sorry. Oh, 92. Sorry. Right. And what's the other one?
50.5 to 100.
Okay, we're done then. So it's about there.
Right. Now to complete the cumulative curve, we have to draw it from the origin straight to the last point. And this is not a curve of best fit. So please ensure that the line that you're drawing pass through all the points. Awesome. Now that curve, this curve, the curve that the cumulative frequency curve make, and all cumulative frequency curve make something like this, and the curve is called an Ogive curve. Everybody understand that?
Yes.
Miss, can you repeat that, please?
The curve all cumulative frequency curve, they make the same shape, and the shape of the curve is called an ogive, O-G-I-V-E.
It's like an S, an elongated S. So the shape of it is called the ogive. It's a really weird name. I don't know. That's how they spell it. So the shape of the curve is called an ogive.
Now, from this curve, they require you to answer some questions. Now, all of the questions that they ask, you will be required to answer them from this curve. It's not something that you're going to calculate in your head or try to figure out based on what in your head. But the question that follows, all you have to do is to answer them based on this curve. So the next question, the C section said, estimate from the graph the median mass of the packages. Now, what do you know about median?
In the middle.
It's
In
the
the
number that is in the middle.
Right.
But
No,
first you have to change them from ascending to descending.
good. But we have a graph. We already assigned them from ascending to descending. Look at it. Isn't everything organized from the smallest to the largest?
Miss 30.5.
All right. How do you get 30.5?
Miss because you tell me go mass.
How do you find it to be the middle mass? Tell me how you get 30.5 to be the middle mass.
Miss because I have 2 mass down at bottom, and then I have 2 up at top, and then I have 30.5 in between them.
30.5 in between them. What's the total amount of mass that we have? What's the highest mass that we have?
100.
5.
All right, let me show you something. There are 100 packages, right?
Right.
Right. Now, all we need to do is to find half of the 100. What is half of 100?
50.
50. Now, using your graph, you're going to go from the 50 mark. All right, so look at what Sir Stevens is doing. So because 50 would be the what? The middle of 100, right? You're going to go across with a broken line to where it touches your graph. No, you see, anywhere it touches your graph, you're going to go down. You're going to go down straight to where it touches the graph on the x-axis. And you see, anywhere it touches your x-axis, that's the median mass. Any number where it fall, right down on the mass, that's the median mass. So that not spell right. Everybody see that?
That would be 24.5.
Right, so anywhere on your graph, it touches, that would be the median.
Just remember that whatever you get, whatever value you get, that's what they're gonna measure it off, because they usually say estimate. So everybody gonna get something slightly different because everybody curve is slightly what? Different. All right. What was the answer? What, somebody got something?
24.5, I got so.
Okay. Hey, somebody went almost correct though.
You got 24.
All right, so everybody getting something slightly different, right?
Right, so because it said estimate, as Sir said, the person's answer might vary. Everybody understand how we get the median mass?
Yes, half of the packages.
Yes, ma'am.
Cross and
Miss
down.
Lewis,
Yes,
can
sir.
you want to touch on upper and lower quartile?
Go ahead, sir.
All right. No, I was wondering if you want to touch on it. Or you want me to go ahead?
Go ahead. You go ahead, sir.
All right. So, okay. So you have something called the upper quartile and the lower quartile. All right. So the median would have been in the middle. All right. So, all right. So you have packages from say 1 to 100, right? Get that? So the middle package would be at what? 50. Let's call it Q. So we call Q the median. All right. Why? Oh, I said spelling.
DI.
Yes, sir.
Boy, spelling thing. All right. So you have something called the lower quartile, LQ. And we call it Q1. All right. So Q1, the lower quartile is just a quarter
Of
of
50.
100. What's quarter of 100?
One number.
25. All right. And then we have something called the upper quartile, which is called Q2. All right. So the upper quartile is just 3/4 of the 100. What's 3/4 of 100?
75.
75. All right. So they can ask you to determine the upper quartile.
Good
So,
morning.
morning, Winsome. The upper quartile would have been 75. So do me a favor, locate 75 from me on your graph. So 75 would be between 74 and 76, not true? So locate for me, take a ruler and do something like this, just like how Miss Lewis had taught you how to do the median. And then bring it down. And tell me where you get. You're supposed to get something like my line of source. You're supposed to get 30, about 32 point something. I don't know.
32.5 by 32.
Okay. So my graph can actually work though, because not true.
Sir, I got 32.
You got 32 flat. Okay. So Q2, which is what we call the upper quartile. All right, let me do it down here. So this is Q2. Hey, I open and draw the graph, you know. Come know someone, you know, they are open up the graph. So this is 32 kilogram. And the median was what? 24.5 kilo. By the way, you get what you get here? All right, that's Q2. This is what we call the upper quartile. So Q1, which is lower quartile, is going to be 25. 25 is between 24 and what? 26. So something like so. Bam. And I believe it's about 16, about 15.5 or 16, thereabouts. Tell me what you get.
Oh, so the 50 will considered as Q, and the one before is Q1, and the one
Right,
after.
right. The median is referred to as Q. The upper
Okay.
quartile is referred as Q2, and the
Okay.
lower quartile is called Q1. All right. What you got? Supposed to be was 16 or something like that, 15.5 or 16.
I got 15.
What you get? 15?
15.5/16.
All right, let me just use 16. So the lower quartile, Q1, is 16 kilogram. Okay? Everybody
Sir.
following? Any questions?
Sir,
Yes?
sorry, in between, where are they count by?
All right. All right. So it's a Q1. Q1 is a quarter of 100, which is 25. 25 is located between 24 and 26 on the cumulative frequency curve. So look for the line that's between, it's in between 24 and 26.
Sorry, that's why they ask where they count by because me now get it 25 to this one.
You're not getting 25?
Two.
All right. Can you locate 24 on the y-axis? 24 is 2 lines above 20, you know. Agree? So you have 24 and the next line will be 26. So 25 would be between 24 and it's in between that space. And you just carry it across. Upper quartile. All right, so Q2 is upper quartile, Q1 is what? Lower quartile. All right, you getting the 16 now or the 15.5? All right, so sometimes, you know, they'll ask you to calculate the, all right, the interquartile range, the interquartile range. The interquartile range is just the difference between Q2 and Q1. All right, so in our case, Q2 is what? 32 and Q1 is 16. All right, what's 16 from 32? 16, not true. So the interquartile range is what? 16. Get that? Any questions? You want me to say it again?
Okay, sir, go ahead.
All right. What I'm saying, sometimes they'll ask you to find what we call the interquartile range, IQR. The interquartile range. The interquartile range is just the difference between the upper quartile and the lower quartile, which is Q2 and Q1. So in our case, it's 32 subtract 16. Do you get that?
And that is an approximate, right?
Yeah, man, everything is going to be an approximate because the 32 is an estimate. The
Okay.
16 is everything is an estimate. All right. But what examiners are looking for, you see, if you read off 32 and then 32, you're gonna get marked down. Get it?
Okay.
Yeah, man, that's the only way you're gonna get marked down. All right, now sometimes they can also ask you to find what we call the semi-interquartile range. The semi-interquartile range, it just divide the interquartile range by 2. So it's actually IQR divided by 2. So in our case, it will be just what? 16 divided by 2. which is what? 8 kilogram. All right. So you have the interquartile range and you have the semi-interquartile range. But if you just walk in this Zoom link here and see all of this, you might be saying, boy. All right. So let me see if I can send this to one WhatsApp group. And I'll send it later. All right, can I erase this?
Yes, sir.
All right. Ms. Lewis, the question not done.
One more part leave to it.
One more to cover. Okay, all right. But I gave you an initial piece. I open and learn, because this might come a couple days from now, and you know. So no, I should never erase that. True. I think. All right. Hold on. I think that's it. Miss Lewis, you can take it away.
All right, so thank you. All right, so the last part of the question said the probability that a package chosen at random has a mass which is less than 35 kg. How do you think that we go about finding that? Is there somebody, I cannot hear you properly if you're saying something.
I'm not seeing the question again.
The probability that a package chosen at random has a mass which is less than 35 kg.
Not on the screen.
Yes, I go divide.
Divide what? What do I divide?
I don't know. 8 by 100.
Remember, I know, listen, remember I said that the question that follow, you have to use a graph to find them. So how can we locate package that is less than 35 kg? How can we locate the probability?
Oh, by 20, go down.
All right, the first thing that you need to do is to identify what on your graph.
The median.
35.
35 kg, because 35 kg is in the question. 35 kg, sir, in the mass section. The person that is speaking, you're very low. I'm not sure what you're saying. I can hear you saying hello, but I'm not hearing you properly.
I'm not seeing anything on the screen.
You want to rejoin?
Okay.
All right, so the first thing you need to do is identify 35 kg on your graph. Remember now, we are checking package that is less than 35. So you have to identify 35 on the mass section of your graph, which is the x-axis, up to the line, right? Then you go across. When you go across, you will find out how many packages would be less than 35.
I got 80.
You got 80?
Little above 80, but estimated 80.
I get 82.
Sir, I got 80.
Make sure that's right on what you get.
All right, because it's an estimate, right? So everybody's not going to get the same thing. All right, so for persons who got 80, you use your 80. Now,
All right.
how do we find?
Let me write 81 for, you know.
What would be, how would we find the probability though? So when you identify 35 on the graph, you go across, you get 80, you get 81. How would you find the probability?
That's what I don't know.
All right. Remember now, we're dealing with the package side. How many packages do we have in total?
100.
100.
So I'll subtract 81 from 100.
No. Probability. Remember, we have probability. Well, how do we write probability?
In ratio.
In ratio or as what?
Miss Lewis, is it less than?
Yes, sir. I said less than.
Okay.
So we can write probability as a ratio and what else?
Equation.
Or as a fraction. Right? So if we want to find all the packages that are less than 35 kg, what would we have? 81 over what? Or 80 over what?
100.
80 over 100. Now with probability, you have to simplify probability to its lowest form.
All right. So Ms. Lewis, I think probably a good way to is just like to define what probability is. So basically, probability is what you want divided by, you know, your total possible outcome. All right. So, or your favorable outcome divided by a total possible outcome. So your total possible outcome would be out of what? How many boxes? 100.
100.
Right. So basically what they're saying, my favorable outcome would have been how much. All right. What am I trying to say now? They must say how much box out of the how much box weigh less than 35 kilogram out of the 100. You follow? And it turns out, according to our estimate, it's going to be 81 of those boxes. All right.
Sure.
Yes.
All right. Good. Yes.
Right. So in other words, 81 at the box them and below out of the 100 are gonna measure 35 and less. Get it? You following now?
Yes, sir.
So what's the answer? Be 0.81. And that's a probability. Just to make a note, a probability can't be more than one, yeah?
Okay, but the formula I'm seeing is probability, and you have in bracket, is that x less than or equal
Yeah,
to?
it's less. Yeah, I was trying to write it properly, but that's how they write it in math. You know, but you don't have to do that. You just put 81 over 100. You know, if you want to be fancy.
Okay.
I have a question for you guys.
Sir,
Yes.
ask a question.
All right. No, the question says, listen carefully. Ms. Lewis had said the question. What is the probability? Ms. Lewis, read the question again for me. I can't see.
The probability that a package chosen at random has a mass which is less than 35 kg.
Less than, not true.
Right.
Okay. So so this I should probably change this to less than. So that was less than equal to. Suppose the question didn't say that. Suppose the question says, listen carefully. What is the probability that a box chosen at random
It's greater than.
has a mass that is at least 35 kilogram. Another word for at least is more than.
Greater than.
So when we say less than 81, we are going down, not true? Agree?
Yes.
But if I say at least, I'm talking about more than. So you'd have to go from 81 go up to the 100, not true? Do you get that?
Yes, sir.
So it will be 81 from 100. What's 81 from 100?
20. Wait.
19.
19.
It's 19. So 19 at the box them for Amazon are what you call it? SSMC? What's the name? You know the go on?
Yes, SSMC.
Yeah, man,
Minecraft Express.
Don't near do you a thief, you know. Yeah, man.
Yes,
That man,
sir,
I don't like that one. Anyways, so in other words, what am I trying to say? Out of the 100 packages, 19 of them have a weight that is at least 35 kilograms. So if I fling in the word probability, you just divide that by what? 100. You follow? So the probability that a package has a weight of at least 35 kilograms will be 19 out of 100. And that will be what? 0.19. All right. I think that's it. Not true, Ms. Lewis.
Yes, sir.
probability is always less than 1.
It can be 1. No, it can be 1. For example, if I ask you, what is the probability of you dying? I hope I'm not saying something like, don't take it personally, but I'm saying for a probability to be equal to 1 is something that's sure to happen, not true?
Okay.
I'm saying? Yeah, so what's sure to happen? That we're gonna die one day soon, not true? Agree? So the probability,
Yes.
when a probability is equal to 1, it means that it have to happen. All right. So if I ask how many students in this class, right? How many students in here now? If I ask you the probability, we have 26, no, subtract 2 from that, 3 from that, 25 students, right? So I ask you, what's the probability of students sitting in this Zoom meeting on pass maths Wednesday? Out of the 25, what would it be? For me, I would want 25 or 25, don't you? But
Yes, sir.
yeah, that's the ideal thing, but is it gonna happen? Yes. All right. So a probability can be equal to 1, but it can't be more than 1, okay?
Okay.
All right. Okay, so we have one more presentation. Thank you, Ms. Lewis. Ms. Lewis is one of my colleagues.
No problem, sir.
Yeah, man. Thank you so much. All right. Ms. Coward, are you there?
Yes, sir.
You there? All right.
I can share my screen.
Not even know what I'm doing. Which one am I doing? Let me stop share first. All right. So Ms. Coward is going to. Is that again?
Sir, would you like to share the question for me, please?
All right. Hold on. So Ms. Coward is another colleague of mine, and she's going to. We're going to look at something called line graphs. All right. So what we did a while ago was what we call a cumulative frequency curve. and I hope you learned a lot, because a lot was said in that thing, not true? Whole of something was said. All right. You see a line graph? Hold on, I'm gonna try find a line graph, you see? A line graph is used to show progression. For example, sales at a store, you know, car sales, something like that. You know, the temperatures in Montego Bay for the past year, last year. So line graph is something to show you progression or digression or a fluctuation. All right. So you're not comparing, you don't really compare the temperature. You just show us about it go up or go down, or, you know, for example, gas prices, you know, or food prices. Those are going up, don't you? You know, I think someone should do a study on inflation rate and stress level. Do you think that's worthy? No? All right. I'm trying to share this question. Let's have another little challenge. Well, that's not gonna work again now. All right, I think I got it. I think I get it. Can you all see?
Yes, sir.
All right. So let me, Miss Cord, you can take it away, please.
Okay, sir.
All right, so after Miss Cord's presentation, we're going to take another 20-minute break. All right.
All right, so what's presented on the screen is a line graph, as Mr. Stevens said, and the question or the statement says the line graph below shows the monthly sales in thousands of dollars at a school cafeteria for the period of January to May 2020. Sir, we can wait. So go up, sir, and go up.
What? Hold on. What do you mean up? Like you mean down?
Yeah, down. Sorry, down.
Yeah, down.
So the first question says, copy and complete the table below to show the sales for each month. They already give you January and February. So now we're going to use the line graph to find February, April, May.
All right. So give them 2 minutes to figure it out. 2 minutes to figure out February, April, and May. Yeah, don't figure it out, man.
So when you look at the side, it tells you the sales in thousands, and then the y-axis, the x-axis in month. So we're going to find for February. So you're going to read the line in between February and straight across to the sales represented in thousands.
So 35.
Hold on. Do me a favor. Can you post your answer in the chat? Do me a favor. So, Ms. Coward, what, February?
Yes, sir, February.
February and what?
April and May.
And May. All right, do me a favor. Read off those values and post in the chat what you get for February, April, and May. All right, you can just put F and a number, comma, A, no stress. 3 minutes to do that. So you're gonna read out the value, quickly, please. Let me see if you guys are participating. Can you put it in one chat, please? Like, it's gonna be complicated. Just put all 3 answers in one chat. Okay, Ms. Scott, take it away. I think most persons are saying 35, 15, and 10.
Okay, so that's the correct answer. I think it's
Okay. So it's
So February is 35, yes.
Mhm.
April is 15, and May is 10.
Beautiful. All right. Let me
Carry it down, sir.
right.
So let me write it to you. 10. So February.
All right.
So the next question reads, between which two consecutive months was there the greatest decrease in sales? So we're going to have to find the decrease of sales from January to February. Sir, where you going? Okay, yes. From January to February, February to March, March to April, and April to May. So you guys do that and write the answer in the chat.
Sir, I can't see the graph fully.
No, use the number from the table below. So you know that January is 38,000, February is 35, and so forth.
You can use the table or you can use the graph to actually work it out. But I guess Ms. Carter wants you to use a table. I think the table is actually more effective.
Yes, sir, it is actually.
More effective, yeah, on the graph.
Okay.
What does consecutive mean, class? If I say 2 consecutive days, give me 2 consecutive days. Give me 3 consecutive days. Monday, Tuesday, Wednesday. You see that?
Okay.
Yeah, it's one that follows right after the other, right? So consecutive means right after the other. So 3 consecutive months are, give me 3 consecutive months.
January.
Right. You don't skip them. All right, so post your answers in the chat. Your answers in the chat. Just between which 2 consecutive months was there the greatest decrease, not increase, decrease in sales? All right, I'm only seeing. Okay, I'm seeing only one response. Come on. All right. Nicalia, it says months here. You're giving us Monday and Tuesday. Oh, you're answering me. Okay. Okay, I'm seeing 3 consistent answers. All right, I need 2 more responses. Come on, time is going. Okay, I'm seeing March and April. Let's do it, Miss Cord. Take it away.
Yes, sir.
They're saying March and April.
All right, so that's the correct answer, March and April. But how much was it decreased by? $12,000. Okay. So next question. Calculate the mean monthly sales for the period of January to May. How you calculate the mean?
You add up everything and divide it by the total amount of months.
Okay, so do it.
117.
I only hear one answer. Anybody else want to try?
125.
No. You're warm. You're warm. But remember, the mean is you add up everything and divide it by the total amount of months. Anybody else? Let me see in the chat. 1, 2, 3. 3 answers so far. Anybody else want that?
25.
All right. So yeah, so the mean monthly sales for the period of January to May 2020 would be 25. Remember that the mean is you add up everything and divide it by the total amount of items you have, or days or months or years. Next one, the total sales for the period January to June was 150. Calculate the sales in dollars for the month of June. How would you attempt that question, realizing that June is not on the chart?
Whatever you add for January to May, you just minus from the 150.
Good job. That's exactly what you're going to do. So you have the sales from January to May and you minus it from the January to June. So what would be the answer?
25,000.
Okay. And then you have the last one. 25,000 is correct. Comment on how the sales in June compared with the sales in the previous 5 months. So this is not a working out question. This is where you actually explain. So what would it be?
The highest sales.
No. Based on, look at question 1, 2, 3 and compare it with the question 5. So you know that the sales for June would be 25, right? So
Right.
you compare it with everything else that you have in the chart from April, May to June. What is the comparison?
Goes up by 20.
No. So listen, the sales for June was 25, right? What was the mean monthly sales for the period of January to May?
125.
25.
25. So you realize that the mean monthly sales and June have the same sale amount, right? Understand?
No.
So the total amount of sales for January to May, mean monthly sales is $25,000, right? And you realize when we calculated the total sales for January to June, we got $25,000, right? So you realize the mean monthly sales for the 5 consecutive months and June is the same amount, right?
Right.
That's one comparison. Then the second one is that you realize January and February, January and March. Hello? You realize that January,
Yes,
February,
you're
and March.
saying 25.
The background noise for somebody is loud, so I'm not hearing who's speaking.
Yes, I'm trying to say something because I'm trying to wonder, I'm trying to figure out how you get the 25,000. Shouldn't it be 25 instead of 25,000?
Remember the graph said that the sales is represented in thousand. So the 25,000. So we're going to further go down and say that January, February, and March had the highest sales. However, April, May had low sales, but then when it went on to June, the sales went back up by a little bit. Getting it?
Okay.
Understand?
Oh, miss.
No, I'm not.
Mr. Stevens, you want to help me out a little bit?
Miss, you not have no marker?
Miss.
Yes.
All right.
Miss, my internet chip out. Was the numbers correct for February, April, and May?
Yes, they were.
Miss, I can go back and use the please.
Mr.
All right.
Stevens?
All right. So this all right, right?
Yes, sir.
That good. And what was this? What was February again?
35. Something.
35.
April was 15 and May.
Sir,
10.
Yes.
probably it's because, sorry, it's not 38,000. It should be 38,000, 35,000.
For February.
So when we do the median, that's number 3, we get 125 divided by 25, divided by 5. So we get the 25 flat, not the 25,000, because that part probably they did not do the 1,000 part. So probably that's the part they are mixing up. I don't know.
Yes, because we're doing in thousands. Yeah.
All right, can I say something quickly? All right, just look at the table. And in the table, we have months and it says sales in thousand. So even though we have 38 here, it's 38,000. Right? So for February, even though we have 35 here,
Right.
it's 35,000 because it said sales in thousands. Not just 35, but 35,000.
Oh, so if you just add the 30 to it.
If you want to, but you don't have to. If adding the 0 to the 35 make it more easier for you to understand, go ahead and do that.
What was the average, by the way? 25,000?
Yes,
Yes.
sir.
Okay. So what's a comment on how the sales in June compared with sales in the previous 5 months?
Yes, sir.
Oh, hold on. Mr. Swagwan. So the total sales for January to June, is 150. So basically, Mr. Swagwan. So basically, you have a next column, not true? So you have June, right? That's not true. So what am I trying to say? If you're to add up all I number them, all right, you'll get 150K. So that means if you're to add up January, if you want to find June, just subtract.
So you go add up all of them.
Right. Sum them there.
Subtract.
And subtract from that to get June. That's basically it. And so it's It's 25, Andrew.
Yes, sir.
Yeah, man, it's 25. 25,000, but what they do, they choose not to write the. Sometimes what happens, you know, they don't want to open 00 them. If you look at government papers or financial reports, when monies are in millions and, you know, just to avoid the open 00, just to put quote unquote millions, thousands, or whatever. All right, so if you look at the even estimates of expenditure in the budget or whatever, those big papers, financial document, if you do accounting, sometimes they just use these methods just to avoid the you know the nuisance of the over 00 them. All right, it says comment on how the sales in June compared with the sales in the previous 5 months. Well, I would say there was an increase, not true? Agree? There was an right, Ms. Coy?
Yes, sir.
There was an increase. So what happened? It's 2 months, right? So you'd say there's an increase. Obviously, it's an increase.
So what she was saying, sir, it's the same with the mean of January to May. It's the same figure.
Yes.
Oh.
Sorry.
Hold on.
That's
The mean 25.
Hold on. From January to May is 25?
The average was
the
25.
sales.
And it's the same between 1 month, just for 1 month of June.
People, that question, you know. Well, so you compare 1 month with the previous 5 months, basically. So the total sales in the previous 5 months is 125, correct?
Correct. And the average would be 20 for those 5 months.
Would be 25. Okay. So basically, you know, you probably, well, there wouldn't be any, if you're gonna use that, there wouldn't be an increase then. It would basically be what? The same. All right.
Yes.
So you said no change.
I mean, I understand what you say. And you can go over number 2.
You mean to answer my choice?
Let me just say.
If you're gonna compare, I mean that is it. If myself compare 5 months and the 5 months are 25K with one next month and you make 25K in the next month, there's nothing to compare. I see how much money you make.
Okay, so the answer with number 2 would that be like, you would have just put on January and maybe because we hear them as like something.
Number 2, and number 5 with that.
No, but a number 2 me they ask you about.
Let's start at number 5 first, okay?
Question, sir.
Yeah.
What do you mean by no change? Because what I am seeing here, the average for January to May, the average amount of money that is made, or based on what the table is saying, the average that is made is the same as June. So that would have been a comment. So the average for the first 5 months, previous 5 months is the same as June. Or you could say that there's an increase
in sales.
Increase in sales for the first for June. So when you can say there's a decrease from January to May and an increase in June. There's a decrease from January to May and an increase in June.
Yes, sir, because if you write no change, it's gonna be when we add up everything, the 125 versus the 25. So there has been a change.
All right, so I guess the problem is that one, are we comparing the average? All right, you have a point, because then no, what some persons were doing, they were comparing the average for the past 5 months with 1 month sale, which would be kind of unfair, not true? Because
Right.
yeah, it'd be unfair to just compare the average of 5 months to what, but you just compare the total sales with 1 month with another sales. So if you're gonna look at that, then it will be a decrease, because for the 5 months, the total sales was what? 125. And for June, what was it?
25 only.
Right. Okay. So I think that's the better route. Okay. I guess probably the rationale for comparing the 5 months with June, probably, you know, June is vacation and summer, and you know, so you know, like probably saying that you know, like Jan to May would be like a downtime for most car sales. So they want to compare the downtime with someone expectation of summer. People want to travel, people want to go places, etc., etc. So I guess if you look at it that way, but I think what we did wrong was to compare the average of 5 months with an actual value of 1 month, which we can be unbalanced. Better you compare the sales with the sales. If we do that, it will be a decrease. All right. So I would say there's a decrease. But you can't just put decrease alone. There's a decrease of what? So it's from 125 to 25. So there's a decrease of 100 grand, not true?
Sir. Point to that you're making. You cannot compare 5 months
to one
as a group to just 1 month. So what you can say is that there's a constant, which word to use now? A consecutive decrease from January to May and an increase in June.
A consecutive decrease.
From January, because each month it keeps decreasing. So January was 38, February was 35, then 27, then 15, then 10. So there's a consecutive decrease between the months.
Okay.
Right? Over the 5 months. And then you can say there's an increase in June, because remember the question were 2 marks, you know, and you have to write for your 2 marks.
So you're saying there's a consecutive decrease from
January to
June.
And an increase in June.
And an increase in June.
Right.
Okay.
Because remember now, we have to look at the marks of the question to what we're writing.
All right. Honestly, the question is misleading. Because should we, how would know compare, like do that, or just put everything in a bungler? Well, I don't know. I think what you're saying is probably a safer answer.
Yes, because only between that May, June, we have a increase.
But you know what I'm saying? What if it was not a decrease? What if it fluctuated up and down, where you get right? Because in this case, it decreased, so we could have a nice fluent phrase. But what if it fluctuated up and down? So I would say it's a poor question. The question is good for this, because you can have a nice word phrase to say, boy, it steadily what? Decrease. All right. But you know, man, this is a question that could be a problem, not true? So you say it's a steady decrease. What is it?
A consecutive decrease.
No, you can't. No, you can't say consecutive decrease. It would mean that it would mean that it will go down. It will go down by the same amount every month.
Okay, so sir, I would write there's a decrease from January to May and an increase in June.
Right. So a decrease from January to May, and what? An increase
in June.
in June.
Or to add to that, to explain for the full 2 marks, I'd also add the average. The average for January to May is the figure as the June.
No, but that's not true of the thing, because then you're not gonna say two the 1.5 there's some ambiguity there, Andrew.
For the 1 month.
To compare the average and the 1 month. Because it's the same thing. But the question then was if we compare the average still, you know. Just compare the sales, yeah. In the previous all 5 months. All right. The person what said something about number 1, number 2, between the 2 consecutive months. You still want me to explain that? All right. I'm not sure.
Yes.
Okay, all right.
I'm sorry, sir. I was having internet issue. Could you repeat how you get the comment for number 5?
Miss Coward. Coward, you still here?
Yes, sir.
explain again.
Oh, what, sir?
Number 5.
Number 5?
Mm-hmm.
You're basically comparing the sale of June to the rest of the months. I was saying, and Miss Lewis was saying the same, and you were saying the same, that when you look at April and May and June, you realize April and May, there was a decrease in sale, right? And then June went up in increase in sale. So January, February, March, increase, April, May, decrease,
Okay.
and then increase
Okay.
again.
Understand.
Okay.
Yeah, I think the confusion came about by trying to compare the
Comparing
average.
all 5 months.
Right, all 5 months in one, and then comparing, with 1 month. But then that wouldn't be a good thing, because you can't compare average with one data. Yeah.
Yes, sir.
All right. So
This is
all right. So let's look back. Let's look back at number 2. It says, between which 2 consecutive months was there the greatest decrease in sales? So I guess probably if you do something like that, you lose what's that? That's what, 3 grand?
3.
Yes,
right?
sir.
So you lose 3 grand so, and
8
grand so.
12
grand
and 5
grand. So the least, the greatest decrease would have between March and April, because that's where what you lose, what, 12 grand. That's where you lose the most money, not true? That's where you go.
Yes, sir.
Yeah. Which 2 consecutive months did you lose the least amount of money?
January, February.
Right, January, February. That's where you go. So enough of that something we do in our head, like if you do like a business, so boy, much money we make that time, and much, we do it in our heads, like if you do like a business. Yeah. I want to know which month did you lose so many sales? That's why when COVID I go and lose so much sales. I like a thing there. Right. All right. So it's 10 minutes to 1. So we're gonna take a break now. All right. So thank you, ladies, my team members, Miss
You're welcome.
Miss Coward and Miss Lewis. Thank you for participating. I don't know if you guys want to stick around, but when we return, we're going to look at quadratic curve, plotting a quadratic curve, and then we're going to look at a linear programming question. All right. All right. So it's 12:52. So we'll return next. We'll resume the next 20 minutes. All right, we're good. That's it. So if you can stay online, stay online. All right. All right, now before we can start off with this, hold on, let me locate a graph before I continue. So many things on this computer here.
So I'm not seeing the screen.
Yeah, I know. Give me, I'm just securing a graph, people. Don't worry yourself. Don't worry yourself. All right, in the meantime, can you make another, can you make an L on your graph paper? Like a big L. That's what you're gonna do, okay? Don't label it though here. Just make an L. Just in the meantime. I'm just trying to get my graph. Are you guys see my graph?
Yes, sir.
I'm gonna switch to the question now. Which part is it again? G's and P's. Are you seeing the question now? No? You still seeing the graph? Are you seeing a graph or are you seeing a question?
The questions.
Okay, cool. All right, now. Before I start, you see? You have something called you see these signs, these symbols? What does this mean?
Greater than or equal to.
Greater than or what? Equal to. Another phrase you could use is at least. Yeah, you could say at least. And then this one is what? Less than or what? Equal to. Or you could say no more than. All right. All right, so the first question says, hold on. Let me. All right, so as I said before, that's less than equal to, that's greater than or equal to. Okay, no, it's a shop, a owner of a shop wishes to buy X guitar and Y violin to satisfy the demands of his customers. The number, check this out, the number of violins must be less than or equal to the number of what? Guitars. For 1 mark, it says write an inequality to represent information. How do you write that? First of all, what is an inequality? Well, these are inequality signs, not true. So these are the signs, the inequality sign. So all right, let me just go ahead. So it says the number of violins, right? So what we use to represent violins?
Why?
Why? So therefore, the number of violins, which is Y, must be what? Less than or equal to the number of guitars. And we use X to represent what? Guitars. And that's the answer. Follow? Pretty straightforward, don't you? Any questions? All right, let's look at this now. It says the cost of one guitar is $150. Let's stick a pin right here. So, class, if I say, see, write an expression in algebra to represent this, what would you write? All right, let me ask a question. How much two guitar will cost?
300.
How much three guitar will cost?
900.
Right. So you want to know, would this be an algebraic representation of that statement here, 150x? Because x can change to 1, 2, and 3. So when x is equal to 2, I'll get the cost of what? 2 guitars. If I replace x with 3, I get the cost of what? 3 guitars. So this 150x would be a true algebraic expression of that statement. Correct?
Yes, sir.
And what are we buying? We're buying what? Guitar and what? Violin. So a two something. So and in maths, oops. What I want to say? And in maths is actually plus. What would you write for the expression for the violin?
300x.
300y.
Half right. It wouldn't be x.
300y.
It will be 300 what? Why? Because violin is represented by what? Y. All right.
And that will equal to the 4,500.
All right. So you're half right. You're half right or you're half wrong. Which I prefer? Half right or half wrong?
Half right, sir.
Half right. All right. So the question says write an inequality, not an equation. So if you put equal 4,500, you'll get it. You'll probably get 1 mark. All right. So let me ask a question. If you're given 4,000, suppose somebody give you 4,500 right now in your hand. All right. And they said to go downtown and purchase 2 items. Let me ask a question. Would you have greater than or equal to 4,500? Or would you have less than or equal to 500?
Less than or equal to.
All right. What's the rationale?
Less than or equal to the 4,500.
Yes. No, I'm asking you what's the rationale for saying that? Why less than equal to and not greater than equal to?
Because you can't spend what you don't have.
Exactly. Very good. A simple answer. So basically, if you're given 4,500, you can say I have 4,500 or more. All right. It has to be what? Less than or equal to what? 4,500. And then now you're going to spend. So it's going to get what? Smaller and smaller, not true? All right. So would you agree with me that this symbol will go there?
Yes, sir.
And then you'll put your what? 4,000 what? 500. And that's your 2 marks. Look at part 3 for me and see if you can figure out part 3 for me. Post the answers in the chat for me. No? Anybody? For 1 mark. which inequality is represented by at least? Is it greater than equal to or less than equal to?
Greater than equal.
Beautiful. So you know, so the question must, the answer must have that symbol, not true? What are we dealing with? Guitars or violins?
Violin.
And which letter is associated with violins? Which variable?
Y.
Why? And how much of them?
5.
That's the answer.
Really?
They say too easy.
Me I bust my brain and I calculate, sir.
We are calculating. Oh, so. All right, everybody on the same page?
Not really.
Is it up on a leaf? Which leaf is it upon?
Yeah.
Which leaf is it upon? Breadfruit or ganja leaf?
Anyone you.
Okay, what is not following?
Just be greater than something.
No, you have to be more specific. Part 1, part 2, or part 3?
Part 1, all right. So I guess part 3.
Part 3. All right. I would have mentioned that is it greater than or equal to? Another phrase you could use is what? At least. I'm not sure. I don't know if you have that notes. What is the phrase for the other one? No, more than, not true.
More than.
Right. So if I tell you, if I tell you say I have no more than $100, I have $100 and what? Unless if I say I have at least $100, it means that I have $100 or it's a possibility that I may have more. All right. So knowing that now, let's go back to this now. So it says the cost, no, sorry. To get a good bargain, the owner of the shop must buy at least. So because it says at least, you just drop in the symbol greater than or equal to. All right. It's talking about violins, so it has to be Y. Hold on.
But I thought guitar would be a part of that and the 4,500.
No, read the phrase. Read the phrase. The phrase didn't say anything about guitars.
Okay.
Yeah, part 2 spoke about guitar and violin. All right. We're at part 3, you know. So this is the phrase for part 3. So it says to get a good bargain, the owner of the shop must buy at least what? 5 violins. All right. Are we good now? Are you on the breadfruit tree leaf or what?
Yeah.
All right. Okay. Any more questions? Okay. This is so how much marks have we have accumulated so far? We have accumulated how many marks? 4. All right. So this part is the graph part now. So I did say to go to your graph and make an L. Can you see my graph?
Yes, sir.
All right, good. So the scale is very important. Trust me, the scale directs you what to do. All right. So the scale says 2 centimeters on the horizontal axis. Which axis is the horizontal axis? Is it X or Y?
X.
X. And therefore the vertical axis must be what? The Y axis. So it says on the X axis, 2 centimeters represents what? 5 guitar. So what you know? So label your graph, make sure you have your X. So this is 1 centimeter, not true? And this is going to be what? 2 centimeters. So what they're saying, for every 2 centimeters, what do you write?
Count by 5.
Count by 5. So you're going to have 0. You skip a line and say what? 5. Skip a line and say what? 10. So you keep on doing that. Go right across here. All right. And this would be what? Guitars, isn't true? The scale for the y-axis is the same, not true? 5 centimeters, sorry, 2 centimeters represents 5 violins. Am I correct? Or no, so you go. Let me check. Yes, man. 2 centimeters on the vertical axis represents what? 5 violins. All right. So it's the same thing. I'm going to ask persons, is there anybody can open their camera and show me the graph that you're doing? Any volunteers? Oh, yes, make a mistake, yes, sir.
That's what I was gonna point out,
But sir, do it faster, no? Can't get sir. All right, so my graph stops at 20, but I'm sure you want to go further, okay? So let's go straight up. So this is y slash violins. Hold on, that's spelled too right. V for violin. All right. Is there any volunteer that want to show us what you are? Or can somebody WhatsApp? All right, WhatsApp what you have in whatever group. I'm sure you're part of our group. Or if you want to WhatsApp to me personally, it doesn't matter. Let me see. What you have so far? I don't know if the chat. I don't know if the chat can actually okay, so I'm seeing can you just identify your name so I can know who am I? Okay, Shade. Okay, Shade from okay. All right. Okay, I'm seeing Kayla, Shade. Yeah, man. All right, cool. Thank you. I'm also seeing Jessica. Right, correct. Okay, Jessica, label. Oh, okay. Label your Y. Okay. Oh, it's there. Okay, no problem.
I did at the side.
Yeah, man. All right, cool. All right. Let's okay, so okay, so I'm seeing one more graph. Okay. All right, very good. I'm happy to see I'm getting graphs from all different groups that I'm associated with. I'm not seeing anything from, oh boy. All right. Let us look at this question. It says draw the graphs of the lines associated with the three inequalities. All right, so basically what they want you to do is they want you to draw them three lines here, basically. All right. All right. So I'm going to show you to draw the simplest one first. All that sound? The simplest one is part 3. All right. So you're asked to draw y greater than or equal to 5. However, to make life a bit easy upon you, what you really want to draw is y equal 5. Now that is a better thing to look at. So replace it with an equal sign, right? So how do we draw the line y equal 5? Very simple. It's just a line will pass through 5 on the y. Is this the correct line? Is that the correct line? Is that y equal 5?
No, sir, that's y on the x-axis.
That is x equal 5, not true?
Yeah.
Very good. Hold on, still not erased. All right, okay. So y equal 5 would be a line. So take a ruler and draw a line, go straight across your graph paper. But then now you're going to label it as y greater than or equal to what? 5. Okay? Anywhere you're coming in, we'll take the knife. Okay, we're good. Let us look at this line now. Line number 1, y less than or equal to x. Now this is a little bit trickier. All right. So we have, so this was line what? Line 3, not true. The first one was line 3. And this is line 1 now. So I'm going to show you how to draw line 1. So we have y less than or equal to x. But what are we going to do? We're going to write y what?
Equal to
x. Now, how do we draw the line y equal to x? Watch carefully. It's very simple. Y equal X simply means whatever X is, Y is equal to. So for example, if X is 0, what is Y? 0. So 0, 0 is our first point. If X equal to 5, what is Y?
0,
5. So you have 0, 0. Then you have what? 5, 5. Then we have what? 10, 10. Then we have what? 15, 15. Etc. etc. All right, my one stop at 20, but I'm sure your one will go further, okay? And then when you finish, take your ruler, take a long ruler and connect. Oops. All right, so I think I know what the problem. I'm using right. Let's try it again. All right, my line is also straight. So so this is Y less than equal to X. Please do not just make up one line and say, boy, you see, go to Miguel. No, it has to be 0, 0, 5, 5, 10, 10, 15, 15. Just mark all of them. Take a long ruler. Can you guys take a photo and send in the group for me? Let me see what you have so far.
Sir, I'm not using a ruler, okay?
All right, please send me some photos in WhatsApp group. I want to see what you have so far, okay?
So for mine, I didn't use a ruler, okay, sir?
Huh?
For mine, I did not use a ruler.
You have used ruler, man.
Everybody kind of connect.
Look here. You see when I got an exam? Use your ruler. All right, so please put your name so I can refer to you by name. All right, 5328632. Oh, Nikela. Yes, Nikela, you're one good. Yes, Mr. John Mark. Finally, somebody from my class. All right, well, John Mark, look at that graph with John Mark. Yes, sir? All right. Yes. Okay, I'm also Shadi. Yes. Okay, I'm seeing Marlene's just and some persons. Very good. All right. All right. Most of your graphs seem to be correct. All right. Let's look at to draw the second graph. The second graph is a little bit technical, okay? But it can be done. Okay, so the second graph.
Can we change the scale?
No, man, you can only use the scale that's given, okay?
Okay.
Yeah, use a scale because you get marks for using their scale, you know. You get marked for not using a scale. And class, let me tell you something. You're not gonna get a question like this, like a complete. You'll get part of it because of how the exam is structured. All right. So what you'll find that sometimes they actually draw the graph for you. Yeah, and then you must answer some question. So the second graph is what? 150x plus 300y less than or equal to what? That amount, not true? Now, ladies and gentlemen, you recognize that we don't have 150, we don't have 300, we definitely don't have 4,500 on the graph. You all see that? So what we're going to do is that we're going to divide by the highest common factor. What's the highest common factor for all these values here?
50, 100, 50.
150.
0.50? Marlene?
No, 150.
Marlene? It's 150, not true?
Yes, sir.
So if I divide everything, let me tell you something. If somebody asks a question like this, like, what, sir, what if, I mean, let me tell you something. They're not going to give you, they're not going to construct a question. All right? And it reached this point, and you see 150 is 300, and the man will put 4,100. You know, they're not gonna do something like that. The man, let me tell you something. They work out the question already, you know. They work out the question already. So they want things to run smooth. So if I divide everything by 150, I would get what? X here, not true? What would I get for the second part?
2y.
2y. I'm dividing everything by 150. What's this? What's 50? What's 150 into 4,500?
30.
All right. So this is our simplified what? Inequality. But then no, what did I say? To make life easy for us, we're going to replace the inequality sign with a what?
Equal sign.
Equal sign. All right. Okay. Now, how do we draw this line? All right. So this is what you're going to do. Would you agree with me that you only need 2 points to draw a straight line? Agree? Yes. You only need what? 2 points. Because, all right, look, if I put a dot right there, so you know, this line can go anywhere, not true? Yes, that line can go anywhere, so it is not concise. But if I give you 2 points, this line is what? Specific and it's concise. So we need 2 points to draw a straight line. Now, what we're going to do is, see, we're going to say let x equal to 0. And we're going to put x equal to 0 in this equation and see how it operates. If I put x equal to 0, I'm going to get what? 0 plus what? 2y equals 30. Am I correct? I'm replacing 0 in this equation here. I'm replacing x equal to 0 in that equation. And then now, to get y, I just divide both sides by what? By 2. So therefore, y is equal to what, class? What's 2 into 30?
15.
Therefore, one of my points is 0 and 15. That's my first point for this line. Remember, the first number is always what? The x value, correct? And the second number is always the what? What is it?
Y.
The y value. All right. Where is 0, 15, by the way? Is it right here? Is that 0, 15?
No.
Oh.
Axis.
It's
And
on the
15.
y-axis, not true?
Yes, 15 on the y-axis and 0 on the...
So that's 0, 15. All right, then no, after I make x equal to 0, but we need one more point, not true? What we are going to do, we are going to say, make y equal to 0 and see how the formula operates. So if I make y equal to 0, I'm going to get some more space here, man. All right, let me go down here, yeah? So I'm going to make y equal to 0 and see how the formula operates. So the formula is what? X plus what? 2y, but no y is what? 0. And everything equal to what? 30. And what's 2 times 0?
0.
So therefore x is equal to what? 30. So there goes my second point. So what is my second point? I bet some get someone right, I don't know. What goes right here, so?
30.
Smart man. And therefore what? 0 must go there. That's my second point. And where is 30, 0? It's 30 on x. You all see that? So ladies and gentlemen, now we have what? We have our what? 2 points. So on your graph, connect them now. So you have something like that. So this line is x. I'm labeling this line x plus 2y I'd love to see what you have here so far. So please send in those photos in WhatsApp to your groups. Again, let me see what the final product is. Okay, I'm seeing messages from Tequila. All right, so I'm also getting messages from Shade. All right, so just if you use your freehand here, you'll get yourself some problem because you're not gonna get the accurate answers that you need. But
Yes, sir.
I
don't have a rule at hand.
okay, but I appreciate that you are trying.
Okay.
All right. All right, so I'm getting some more messages. Nikela, you know, sir, I don't know. I'm trying. There's a little error. I don't know. Like the line, you know, it looks straight, but I don't know what's happening. Tell man, you have to be accurate. You know why I said that? It's at the top of it. It's at the top. It's at the top here. So my one accurate. It's at the top. It should be at 10-10. Because I did this question yesterday. So it's at the top. The top two line. It must cross at 10-10. All right. But I know in the exam you're gonna be as accurate as possible. All right. Yes. All right. I'm seeing some more graphs. John Mark. Seeing Makeda. All right. All right. We're good? All right. Let us continue. Is there anybody who was lost? Why? All right.
So, sir, question.
Yeah, okay, so let's continue. It says shade the region on your graph that satisfies, that's a keyword, all three inequalities for 1 mark. So pay attention, okay? Let me see if I can use a different all right, let me see if I can use this. All right, watch carefully now. Look at my cursor here. No. Hold on. I'll go on. Okay, no, let's look at this line here. Y is greater than or equal to 5. Would you agree with me that this line down here, so the one that goes to 5, it's actually going up? So imagine that this line is going up.
Hi, get your paper.
All right. Follow?
Thank you, everyone.
And then no, the line y less than or equal to x, it's less than, so it's falling down. It's coming down this way. But this line is what? It's going up because it's greater than, okay? You with me? Nobody answer me. Anyways, so this line here, any questions, class? No, I'm not understanding. I'm going to explain all over again. Let's all right, tell you what, let's go again. Look. The line y less than x means that all of the line are fall down. So it's falling down. It's coming down. Whoops. Come on. It's an eraser. I cheated there. I cheated that one. All right, let's go again. Let's go again. Y greater than or equal to 5 means that the line will go up. Suppose it wasn't greater than. Suppose it was less than 5. It will be going where?
Down.
Down. All right. So imagine in your mind. Well, it has to be your mind, not true. That this line is going up, and while that line is going up, down here, so this is the line that says y less than or equal to x. It's less than or equal to x. This line is coming where? Down. All of it is falling down. So while this line is falling down, this line is going up. All right, but this line here, so the 0 to 15, the last one we draw, it's less than, so this is actually coming where? Down. All right. All right, so I'm not going to ask if you're following me, but I hope you are. So you are going to know. You are going to know. This is my question to you. I'm going to put some sections here. Section A, Section B, Section C, and Section D. Here's my question. Which section of the graph would all 3 lines meet?
B.
All right. Anybody else?
B, sir. I said B.
All right. Let me ask a question. Why B is correct? Why A would be wrong? Why A? Why not A? Which line now cover A? This one, not sure. Because this is falling down. This is fall down, so it now cover the part here. You all see that? And why C could not be the area where all lines cover? Which line not covering C?
The y less than or equal to x.
No man, less than equal to, it means no man, that line is gonna cover it, man. It's gonna fall down.
Y greater than 5.
Exactly. The one that has y greater than 5 now go cover C because it go up. So these two lines are coming down, and this is the only one that go up. But B is the ideal answer because B is where what? All lines meet. All right. So what you're gonna do is just shade the area. So you take your pencil and you shade. And this is what we call the common region. That's a common region. Everybody with me?
Yes, sir.
Or not going up on tangent? No? All right. That's one mark, you know. We're almost there, yeah? So after this, I'm gonna take a break, man, because this was not long. Take a next break and then we come back again and we'll do one more graph, okay? And then probably another graph. All right. So the question says, state the coordinates of the vertices of the shaded region. In other words, they want to know. Let me change the color. To red. In other words, this is a common region, you know. Look. You all agree, right? Oops, that's a common region. What they do, they want the points. And these are the points of the what? The common region. All right. So what is this point here? What do you have? It should have been 10, 10. If you don't have 10, 10, you did something wrong. The line is straight or something right. What's the one on here, so?
5.
5.
Mommy.
And the last one should have been 20, 20 and 5. Everybody with me? Now, suppose you don't get those values, it means something right with a ruler lead or something. Or something. You know, not straight or something. Okay? Let's go to the last part of the question. C. Question says, all right, who wants to figure out part 1? Please, you can figure it out, you know. Figure it out. Somebody figure it out and post it in the Zoom chat. Let me see if we now learn. Anybody? How would you write $60 on a guitar in algebra?
60x.
Right. Because X represents guitar.
So
X
60x plus 100 y.
Right, very good. Because X can be 1, 2, or 3. And we did it a while ago when we were working on the 4,500 row. It's the same idea. Sorry. So the answer is 60x plus 100y. That's it. Don't put an equal sign because it says express. Let's look at 2. It says calculate the maximum profit. No. This expression represents what? Profit, not true? So this is what you're going to do. You're going to use the vertices. All right, so one of the vertices are what? Let's use 5, 5. Let's call it profit 1. So it is 60 times X. But what is X? 5 plus 100y. What is Y? 5 again. Look like S, but sorry about that. Work on that for me, please.
$800.
800, don't you? So you know what? If the shop owner buy 5 guitar and 5 violin, he's gonna make a profit of what?
$800.
But then no, we have some more. Not sure we have 2 more.
Sir, where you get the 800?
When you work out the 60 times 5 and 100 times 5.
Okay, done.
Profit 2 now will be 60 times 10 plus 100 times 10. And what is that?
1600.
1600.
600.
And then you have the last one now, 20 and 5, which is profit 3. Somebody work on that for me, please. It's 20 here.
17.
It's 1700. And isn't that the biggest number out of all of them? So basically money upon guitar. Because if you buy 20 guitar and 5 violin, you make the most money. It makes sense, don't you? Because nobody really use violin. Try true. How many violins do you know? How many you know can play violin? Nobody. Well, I don't know anybody still. Probably do. But how many persons you know can play a guitar? Probably a few. Probably at church or karaoke or one of them places. So that's the answer. So the maximum profit is what? $1,700. And do you see the reason why you need to get those points correct? Those drawings, so because the drawing, how you draw the lines depend on how you get answer the question. So if you have wrong values there, you're going to get wrong profits. All right. Any questions? All right. We're going to take a break, a 20-minute break. I need it. Feeling really tired.
Sir.
Yes.
So what time this workshop finish?
Finish at 6. All right, so we're gonna take one more break. All right, so if you just join us, we're actually on a break. All right.
Okay, so I'm gonna log off and log back on. Like, what time should we come back on?
It's a 20-minute break.
Okay.
All right, guys. Okay, are we ready?
Yes, sir.
All right, let's do a few multiple choice. Let's go back to some more multiple choice. I'm gonna see if I can send all right, let us answer, let us look at this question. Are you seeing this question?
Yes, sir.
All right, so it's pretty something similar to what we did a while ago. All right, so it says the diagram below shows the graph of 3 lines and the shaded region defined by the 3 inequalities associated with the lines. The inequalities associated with the lines is 3y equal x and 3y greater than or equal to x. All right, so basically, they're telling you that this line down here so is 3y greater than or equal to x. So if this is greater than or equal to x, it means that this line is going up, not true? All right. So the question says, state the other 2 inequalities which define the shaded region. So the other 2 inequalities would be what they're saying. This line here would have been what? X plus y something 40 is an inequality. So is this greater than equal to or less than equal to? Where would this line be going? Would it be going up to the right or down?
Up.
Can't go up. Because if it go up, remember saying, this part is shaded region, so it has to be coming down. It has to be coming down, so it can cover the shaded part. See that? So it's x plus y less than or equal to 40. That's the only way we're going to get this part shaded. For this line to be what? going that way, not true? And that way is what? Less than. So this will be the answer for, you know, that one, right? So there's another inequality. This one is this line x greater than or equal to 6. It's going that way. It has to be going that way, not true? So therefore, it's going to be what? Greater than or equal to. So you notice this question, what do they give the diagram, not true? And they want you to write in the inequality. So x plus y less than 40 has to be less than, so it can cover the area. All right. This one down here, so 3y equal x, has to be greater than, well, let me tell you it's greater than for it to be going up. And x equals 6 has to be going to the right for it to cover what? That area. All right. It says the function p equals 4x plus 3 satisfies the solution set represented by the closed triangle region. Identify the 3 pair of points. All right. So in other words, they want to know what this point is. What's that point?
Thirty 10.
30 10. Come on, somebody asleep. So hold on. Let me do a little check. Unknown. I don't know. Who's unknown? Unknown, are you there? All right. Who no answer my take them off of the meeting, you know? Unknown, are you there?
Maybe she have internet problem. Really fast.
Tony Marie, are you there?
Yes, sir.
All right. Shade?
Yes, sir.
Tanisha? Hope? Are you there? Sploma, are you there? No. Aris, are you there? Richard? All right. I take forever to go through everything, but
No, I cook, so that's why.
they're gonna cook.
Yeah, we reach home and I try to get some food.
All right. They're gonna turn the pot. Pot 1/3. All right, the chicken one flip over. Which one of them? What is this point here? It's kind of technical.
6 2.
All right, you're correct, you know. 6 2. Because each line is 1, not true? So this is actually what? 6 2. What about the one up here, so? Isn't it 6?
30.
6 and 30 what? 4.
You got to tell Papa you.
Yeah, man, it's 34. It's one line below what? 35. All right, so those are the 3 points. All right. It says which pair of x and y value makes what? P a maximum. All right. So what you're gonna do is say you're going to same thing we do a while ago. you're going to use this formula here, P. So we have 6,2. And we have P equal 4 times X, but X is 2, plus 3Y, but Y is what? 2. Hold on, no, sorry, I said X is 2, no, X is 6. So this is 24 and 6, so that's what? 30. So what we're going to do, we're going to use the 6 and the 34. To work out profit 2. What's profit 2? What
126. 126.
126?
Right.
Can someone second that?
Yes, sir.
All right, what's profit 3? No, profit 3 is 30 and 10. What's that?
$150.
150.
150. The question says which pair of value makes maximum profit? So the answer will be what? 30 and 10. Follow?
Yes, sir.
That's it. So you notice how this question don't give you, it's not a lot, you know, and they give you the graph for you to interpret it. All right, let me know when I can move on. All right, let's look at some multiple choice questions in the interim. All right, you guys are seeing my screen?
Yes, sir.
All right, work on that for me, please.
20.
Just like that.
$32, sir.
Eh?
20, sir.
20?
20.
All right.
32.
32.
40% of 40% of 8 and not 8% of 40. Sorry.
30.
32, sir.
20.
Percent of 8 would have 32.
The person who got 20, how you get 20?
It's 20. I misread it just now.
How you get 20?
5 years are 40. And if you divide, and if you 5 from that, say just right. You know, so 5 years will be 40. And if you check back 5 times 20, would be 100. So you take out 20 out of that, you'll get that.
Sir, I put 80 over 40, 100 over 1.
Come again, you put what?
8 over 40 times 100 over 1.
8 over 40 times 100. And that's how you got 20. Let's test it now. In other words, it's 20%. It's 20% of 40 equal to 8?
Yes, sir.
It's 20 over 100 times 40 over 1. So that will go, that's what? 5 into 40 goes what? 8. So you're correct. It's actually 20. If you find 40% of 8, it will give you 32. No, sorry. No, that won't give you 32. But you have to read the question carefully, not true? This is what percentage of 40 is 8. All right, so I think that this is the better way. All right. Can I move on?
Yes, sir.
I'm not make it by 6 o'clock, you know. I'm really tired. What time now? 3 o'clock? Because I have one more graph to do, but I don't know if I can manage to do it. Okay, what's that one? Easy.
B. B, sir.
Yeah, B is correct. B is correct.
Yeah.
Because it's 3 decimal places, so 0, 1. So 0, 1, 2, 3. Draw a line. 6 is more than 5, not true. So add 1 to the 0 behind there, so not true. So it's 3.141. Look at number 3.
C, sir.
C.
All right. How did you arrive? That's your answer without using a calculator.
Move the decimal place. Move the decimal to one place.
Okay, someone with a calculator. What does it say?
159.1.
15.91. All right, so you're correct. If you notice, all the answers are the what? All the digits are the same, not true?
Yes.
And so, you know, when we multiply with decimals, when you finish and we want to know where the point goes, we count how many decimal places it moves to the right. So 0, 1, 2. So therefore, this would have been 0, 1, 2. So it's actually 15.91.
So you're sure?
No, I B, C.
I see?
Sir, I got 159.1.
15.91?
Yeah.
Then a B, Mister. A B, Mister.
No, sir. C, 159.1.
Oh, that's, oh. When you use a calculator, that's what you get?
Yes, sir.
Yeah.
That's a C. 159.1.
All right. I think maybe because there's a zeros right here, it goes to one place rather than two. Let me check something. Oh, I see what happened. Is it because the 370 is a whole number? People are smart, you know. Because this is a whole number. And because it's go back two places, it's not going to go back two places. It's going to actually go back what? One place. Because this is actually a whole number, yeah. I was trying to reason it out. All right, if you look at this, right? Both these two numbers are what? Decimals, not true? So 1, 2, 3, right? So it goes three places where? Back to the left. But it's not going to work if one of the other number is what? The whole number. It's actually going to go back one place. All right? And if you're not sure, you can actually work it out. You know? But, yeah.
So basically then, sir, if you're multiplying a whole number by a decimal, it always move one place back.
Well, if the decimal point that you have is like two places.
Oh, you move one place back.
One place, right.
3 decimal place is move 2 place back.
Right. So if I have something like this, 0.411, and I times it by 370. All right, for argument's sake. All right. That should give us something with what? That's only what? 2 decimal place. So if the answer is a 1, 2, 0.34. Use the calculator and check it for me. What is that? Is it by 2 decimal place?
Yes, sir.
All right. And it's because this is a what? A whole number. If there's any question, they're simple and tricky, you know, because all along, I just text a boy, you just count, but I never recognize that one of the numbers, if it's one, is a whole number, you know. I say you're gonna exam and get them wrong, you know. See you myself. If you don't mind sharp, if you don't know where you do, you get the whole of them wrong. If you don't know where you do. All right, look at number 4. And tell me what you think the answer is.
B.
D.
All right. I'm hearing D. What are multiples?
D.
You keep on adding them, not true?
I said D, 12, 24, and 36. All 2 numbers can go into 12, 24, and 36 without leaving a remainder.
So these are the multiples of what? 3. These are the multiples of what? 4. And these are the multiples of 6. So which multiples are common? What's the first multiple that's common? 12.
12.
All right. And then we have, well, I didn't go to 24, but if you realize that the only one starts with 12 is D, then everything else must follow, not true? So the answer would have been equal to D. All right. Look at 6.
Sir. A.
6. Want to explain?
$60 over 100 times 40 over 1. So then get 24. Now put it 25% over 100 times the 24 that we should get. And I end up with the 6.
You are correct. So in a class, you have boys and girls, not true? And what they're saying that girls make up what? 60% of the class. All right, so 60%.
So that 60% is 24.
Right. 6-4 is what? 24. So in that group, we have 24 girls. But it goes further and says that what? Of the 24 girls, only a quarter of them wear glasses. So to find the 25% is just a quarter of 24. So a quarter of 24 is 6. All right. So therefore, A is the answer. Very good. Can I move on? May I move on? Or let me know when I can move on.
Yes.
You can move on, sir.
All right, thank you. Look at number 7. No, this is talking about set theory. All right, any ideas for number 7? It's asking for H complement. What does complement mean in set? Let me illustrate something to you. This is a universal set. Now let us say you have set A. I am shading set A. A complement would be everything on the what? The outside. That's what complement means. Everything that is on the outside. So they're telling you that H is a subset. Sorry, H is a subset of the universal set. And H is what? 3, 4, and 6. So 3 gone, 4 gone, 6 gone. So if I say what is H complement, it will be everything else except the 3, 4, and 6, which is what?
B.
1, 2, and what? 5. Answer is B as in boy. Get it?
Yes, sir.
All right. All right, moving on.
Yes.
Oh, this is a nice one. What's the answer for this one? All right. Now, what is, I mean, you don't necessarily know what this means, but less than is I mean, it couldn't be any of these, that's true. Because all of them are what? Greater than or equal to, oh, sorry, except for this one here, D. Sorry. So the first two ones, what's up here?
Sir, it has a minus, so the sign might change.
Well, I'm trying to get rid of this thing.
Sir, answer D.
Answer D?
I second D.
It's actually D. So it can't be B nor C. And you know, let me try to explain this. It says all right, tell you what, rather than explain, let me break up D for you. Let me show you something. You see this? Spin it around, I get X what? Less than what? -3. Split this part into two now. If you split that part into two, it's just X what? Less than what? 6. All right. So if you read question, describe a set of integers that is greater than -3, but less than 6. Greater than -3. You know, son of D? Because when it's split up D, you know, you get X is less than -3. All right. And you get X less than 6. So the X less than 6 is all right. So this is a problem. But let's look at A. What does A says? Let's try to split up A. So we have -3 greater than X. But we have to put the X on the left hand side. So that's X less than what? -3. And then we have X that is greater than 6. So therefore X is what? Less than 6. All right. So isn't this X less than -3? Yes. And isn't this, sorry, isn't this -3?
Sir,
Hold on.
read the question again, sir.
Oh Lord, I'm sorry. I guess what, man? I realized at this part, I wasn't looking at this part. Hey, I'm tired, you know. Right. So greater than -3 and less than 6. So it has to be D. I'm sorry. I wasn't looking at the first part here, so I didn't see this part here. All right. So my initial answer was correct. Sorry about that. Mr. Lewis, you want to look up them for me? Mr. Lewis. You gone?
I am here, sir.
You want to couple of them for me?
All right, I'm currently on the tablet, but I can run through a few, sir.
All right. Come on, my head is hurting. What about look at number 9.
All right. All right, so number 9 said, if X and Y are two finite sets, simple meaning that you can count what is inside the set, such that the number of X, meaning the number of elements in X is equal to 9, and the number of elements in X intersect Y is equal to 4. So basically, what they're saying is that the middle section of the intersection between X and Y, there are 4 elements inside there. And the number of X union Y, the number in that set would have been equal to 15. So there are 15 elements in the Venn diagram. There are 9 elements in X, and there are 4 between X and Y at the intersection. So they're asking us to find how much is in Y only. How can we go about finding how much is in Y only? How do you think we go about finding that? That would be 5, sir. How do you think we can find what is in Y only? So we could have what? What we could have over there? Our press is able to hear me?
Do you guys understand what this means? It means union, X union Y means that the whole of the something equal what? 15. So all I two circle them are going to equal to what? 15. All right?
Right.
All right, hold on. I think probably this is probably a better way of let me all right, let's move away from the question a little bit. All right, so what happened, you see? You see this box? This box is called a Venn diagram. No, sorry, the box is called a universal set. So the universal set is where you put all the elements from. All right, and let us say we have 2 sets. We have set A and we have set B. All right, so this is set A and set B. Now, A and B could be anything, you know, it could be persons who work at a school, it could be students in a class. Set A could be the number of students who can play chess. Set B could be the number of students who can play domino. All right, or football and cricket. All right, let us use football and cricket. Football and cricket. So you are going to know. Is in the middle? In the middle would be a common region. It will be a shared facility. In other words, you have some students who can play football and what? Cricket. And cricket. Okay. So this symbol here means intersection. Intersection. So F intersect what? C. So let me ask a question now. this circle here, so right? This circle means those who can play what? Football, not true? Agree? But part of the football, some of them can play what? Cricket. No, you see the part here, so? The part here, so? Would be those who can play football, but not cricket. So that's C complement. C with a dash. Or football alone. Football only. You follow? What that mean? It means that they can play football, but not what?
Cricket.
Cricket. Over here, so would be what? Those who can play cricket,
only.
but not what? Football. All right? Let me ask a question. Who you think up on the outside?
Who can play none at all?
Like me. So this will be not football, and not what? Cricket. All right? What do you follow?
So far.
All right, so you what I want to know. You want next thing now called union. All right? You want next thing now called what? Union. So you are going to know. F union C would be all of this. Get it? However, a while ago, we said F intersect C. Now, F intersect C will be the middle part. But F union mean what? The whole thing. All right? All right. Then no. Let's go to the question. The question says, so we have two sets, right? You all agree? And then meet. How do we know so they meet? Because of this. Them say what? 4 is common between what? Set X and set Y. So what I must know, is it? The number of somebody or whatever is in X is 9. So all of X, you know, all of X inclusive of 4 is equal to 9. So that means the answer must be what? 5. You all see that? Because 5 plus 4 gives you what? 9.
The next
So what's
should
up?
be 6.
Eh?
The next one will be 6.
Have to be 6 because 5 plus 4 plus 6 give you back what? 15. Because I'm testing the whole thing, I go equal to what? 15. You all see that? All right. So the answer there is
6.
Hold on. That question is tricky, you know. Well, right just says 6, you know, but look what the question asking for.
Why
What
only?
is what?
Why?
What is NY? What is NY? Everything in a Y. What's everything in Y?
10.
All right. You guys get that?
Want to trick me in the coil?
Yeah, because it's the 6. We know it's our 6 to go there, you know. But the question is asking us to find what? the number of elements that is in it, what? The total set.
You belong in my arms, right next to my heart.
All right. So I'm gonna get some strength a while ago. Where I come from? All right.
30.
Look at 10. Miss Lewis, you wanna work out 10? Look at 10.
Why? Because it's factors. All factors of what? 12 factors of 12 and 9. Because set of all factors of 21. So 21. See?
Hold on.
How would I say?
At 12 and 9, you know, that me do.
Yeah, but remember say 3 can go in about 12 and 9.
The shaded region represent the set of all factors of.
All right, good afternoon again. All right, so for question 10, right? It said in the Venn diagram, X represent the set of factors of 12. The first thing you need to do is to list the factors of 12. What are the factors of 12?
No. So 3.
What are factors? First thing first, what are factors?
A number that can go in
No
without
number can go in without a remainder.
without a remainder.
What are the numbers? What are all the numbers that can go into 12 without leaving a remainder?
6, 3.
So start with the lowest number. What is the lowest number that can go into 12 without leaving a remainder?
1,
1. What next?
2, 3, 4, 6, 12.
4, 6, and 12, right? So those are all the factors of X. Now I said Y represent the set of factors of 9. What are the factors of 9?
1, 3, 9.
1, 3, and 9. Now, remember, Mr. Stevens said earlier that that shaded region right there would be what both elements have in common. Now, looking at the factors of 12 and the factors of 9, what do they have in common? Which number?
3.
3. Right? No. Only 3?
3 and 1.
3 and 1. Right? What are the factors of 3?
1 and 3.
1 and 3. So what would be our answer?
3.
A.
No, let's compare with another number. What are the factors of 6?
2, 3.
So 1, 2, and 3. Is 2 common between 12 and 9?
Yes.
Is 2 common between 12 and 9? No, the answer would be 3 because the common thing between 12 and 9, the factors that are common between 12 and 9 is 3 and 1. And 1 and 3 are factors of 3. Everybody see that?
Yes.
So that question is tricky though, because
The answer is A, right?
Yes. Yes.
yeah, it's A.
Okay.
Yeah, man, that question is kind of tricky, man. Because you what you have to go do? You have to write out all the factors of 12, all the factors of what? 9, and then because it's asking about the center region, right? In the center region, it's what's common. So what's common is what? 1 and 3. But then no, it asks the next question. What number gives us factors of 1 and 3? Basically, it would have been what? 3. All right. If the question had asked us to list out what's common, it will be what? 1 and 3. All right. If the question asks us how much elements are common, it will be what? 2. It's a good question.
Question tricky.
Yeah, man. So if you go next, you just swear some multiple choice easy. I swear some boy, you know, but I don't say it work out. If you don't know what to do, you get the whole of them wrong.
I told me hungry now, still. I can't think straight.
Yo, a real thing, a real thing. All right. Okay, so we have this big one here. It might take a little effort. So let us so we can work on one. I'm gonna try so I can minimize it a little bit, but the questions are a big question.
All right. Question 11. It said 30 students in teacher made class of either a dog represented by D or a cat represented by C or none of the two. It said all the students who have a cat also have a dog, right? So what that is saying is that when we look in the section over here, we have 12 students having a cat, right? We have to understand the statement of what happened. It said all the students who have a cat also have a dog. And if there are 12 students with a cat, it simply means say 12 students also have a dog. Right? So the intersection alone would be what? Based on what we just stated a while ago.
Well,
right, the intersection will be 12, but there is more statement to the question. Right? It said if n number of cats equal 12 and number of dogs equals 16, which of the following Venn diagram currently represent this information? So looking at the Venn diagram below, which one do you think would best fit the information that you just read, that would just go through?
Well, up.
We can't see them.
Well, again.
Zoom out a bit, sir.
Yeah.
What you can do now is just zoom in on your screen to see them better. Just zoom in on your screen.
All right, let's see right this one. So we need to see information. Go back down, look a bit. Yeah, right there.
E. E.
Why would you say D? Right? So based on the information, D would have been the best fit because it says all the students, the key point here, right? The key point there is all the students who have a cat also have a dog. And in the number of dogs, we have 16. Right? And if we're supposed to take away 12 cats from the 16, how much would remain only in dog?
4.
4, right? So for dog only, we'll have 4. For cat, we'll have 12, but between dog and cat, we'll have 12 altogether. So that simply means that 14 students do not have a pet. That's why the 14 is on the outside.
Gotcha.
Everybody see that?
Students. Yeah.
So
Right.
D as in dog.
Another way to put it is, another way to put it, when it says all dog, all who have a cat also have a dog, means cat, the set cat would be a subset of dog, meaning that the set cat is contained in the dog. All right, let me put it this way. Would you agree with, all right, let us say Jamaica, right? The Jamaica that we live in, right? Let us say that's a big set, right? And then we have different parishes, all right? Most of us are in St. James. Anybody in Trelawney right now? No? All right. So would you say that St. James is a subset of Jamaica? Yes, it is contained in Jamaica. All right. So basically, the set cat must be contained in what? In the dog. All right. So therefore, D would have been the best thing. Or in other words, all the members of cat is contained in what? Dogs. All right. Okay, now look at 12. Ms. Lewis, you wanna?
All right, number 12. It said, which of the following pair of set is an example of a disjoint set? When you hear the term disjoint, what comes to mind?
They're separate in the Venn diagram.
Right, they're separate, they're not joined, so there's no intersection within the Venn diagram. Now let's look at our answer to see which one of the sets is a disjoint one. So for A, option A, we have to go through the options now. It said E is even numbers. What are some even numbers?
2, 4, 6, 8.
2, 4, 6, 8. What are odd numbers? And F is equal to odd numbers. What are odd numbers?
1,
3, 5, 7, 9.
Right, good. Now, does E and F have anything in common?
Nope. No.
Right.
We can tell say that we answer. We never have to go through anything else.
Yes, because there's no, in other words, there's no even number that's odd, and there's no odd number that's what? Even. But just for you know, for curiosity, let us examine B and C and D, you know, just so.
All right, so let's look at B, option B. It said P equal multiples of 2. What are multiples of 2?
1 and 2.
Multiple, not
2,
factor.
4.
6, 8.
All right, so 2, 4, 6, 8. Right? And Q is multiples of 3. What are the multiples of 3?
3, 6, 9, 15.
Right, right. Now, if you look at multiples of 2 and multiples of 3, you realize that they have 6 in common, and that would join the set. So that is not the answer. All right, let's look at C now. It said x is equal to whole numbers. What are some whole numbers?
0, 1, 2, 3, 4, 5, 6.
Right, 0, 1, 2, 3, 4. And what are rational numbers? What are rational numbers?
No, Google it if you don't know. Google it.
Anybody find what are rational numbers?
A quarter.
All
I
right,
know.
so
4/8. No.
1/2.
We can represent rational numbers as fraction, right? Now, is 2/1 a fraction?
Yes.
1/2.
No, man, listen to what I'm saying. Is 2/1 a fraction?
An improper fraction.
Right, so 2/1 is a fraction, but looking at 2/1, is it also a whole number?
No.
Right, so right away, basically all whole numbers, let me not say whole numbers because whole number includes 0. All counting numbers are rational numbers and counting numbers are also whole numbers. Everybody see that? Right, so C would not be a part of it, and you get the whole idea of D. Right, so answer would be A because no even number is an odd number.
All right, and then you have just, I mean, multiples of 5, multiples of 10. You're gonna find something common. All right, thank you. Let's look at 13. Hey, now you hear me? I'm gonna give you guys 10 minutes to work out them 4 questions.
Sorry, which questions?
Those 5 questions. Ten minutes. Is it 10? 3, 6. And I tell you no, I suppose 7.5. I get 8 minutes for adult. It's supposed to, the official time is 8 minutes. You have to be fast on the multiple choice, you know. You end up not completing the whole thing.
Beefy number 13.
Lord Marlene. Hold on, man. Hold on. All right, guys. Sorry about that. There's. All right. Okay, so number 13. Louis, still there? Louis gone.
I'm here, sir.
Oh, I think I'm gonna finish this thing at 5, because I'm really tired.
Sir?
I think I'm gonna finish this thing at 5 rather than 6. Yeah.
All right, so what I should go to number 13?
Yeah, man, yeah.
All right, number 13. It said if EC $2.50 is equivalent to US $1, then EC $20 in US dollar is. So basically this question is exchange rate, right? So just like how we know that in Jamaica, $1 US is valued at say $147, right? So basically what they're asking us is that if $1 US is equal to $2.50 EC, how much US dollar is $20 EC? Now we can do this the cross multiplication way, where we can say $2.50 is equal to $1 US. Now, one thing that you need to note is that you have to put EC on the EC and US dollar on the US dollar, right? So the $2.50, you would put the 20 EC dollar underneath that. And the US dollar is what we want to find, so that is our unknown. I can label it unknown as anything, whether it be X, N, A, it doesn't matter. Now you can go ahead and cross multiply. And everybody know how to cross multiply, right?
Yes, miss.
Right. So when we multiply, what would we multiply when we cross multiply?
$20 times $1.
What are we cross multiplying? So that's $2.50 times X, and what else? 20 is equal to 20 times 1. Everybody have that so far?
Yes, miss.
Right, now where do we go from there? How do we find X? What do we do when we want to find X?
Take away from both sides.
We take out, no, all right, so what is the 2.5 doing to the X? The $2.50 cents, what is it doing to the X? Which operation is happening?
Multiplication.
Multiplication, right? So if is it that we want to get rid of something that is multiplying to something else, what do we need to do?
Divide both sides by 2.5.
So we need to do the opposite of multiplication, and the opposite of multiplication is division. So we're going to divide both sides by 2.5. Now, 2.5, everybody follow?
Yes.
Right, so the 2.5 on the left-hand side will cancel out each other. So then we are left X, right? And then 2.5 into 20. Now, this might be a bit hard for you to calculate right away because you're not going to be using a calculator. Now, how can we make this easier for us? What do we need to do? Because we want to make it easy for us to work out, you know, because we're not going to use any calculator. Right on the tip of our head, we do not know how many times 2.5 can go into 20. So what do we need to do? So what we can do is that we can turn the decimal into a whole number. And what can we do to turn the decimal into a whole number?
Multiply by 10.
Multiply by 10. No, we can't just only multiply the decimal by 10. What else do we need to multiply by 10?
The 20.
The 20. Now, when we multiply 20 by 10, what do we get?
200.
200 and 2.5 by 10? 25, right? Now, we can work with this way easier. This is way easier for us to work with because we can look at it and we know that there are 425 in $100. So how much would there be in $200? 8. All right, everybody get that? That clear to everybody?
Yes, sir.
All right, good.
Can we clear the screen?
Yes, sir.
All right, 14. It said at a store, 3 cents on every dollar spent is charged as sales tax. How much is paid as sales tax on a costume which costs $196? All right, now this can be done 2 ways. I remember you're doing it without a calculator, so I suggest you try to find the easier way, right? Now, how can we write 3 cents? What is 3 cents?
0.003.
0.003. Look at it again. 3 cents.
0.03.
0.03. Good. Now, how can we put 3 cents as a percentage? How can we write 3 cents as a percentage? As a fraction, sorry. Percentage, fraction, same thing. How can we write it as a fraction?
3 over 100.
3 over 100.
3 over 100, right? Now, this is one way of doing this. We can write it as 3 over 100, or same thing as 3%, right? Now, if we said that 3 cents is charged on every dollar as sales tax, and they ask us how much sales tax we pay on a costume that cost 196, what are we going to do to find how much sales tax is charged?
Sales tax are like GCT, you know. It's an add-on.
Everybody hear that? So sir is saying that sales tax is the same thing as GCT. So what we can do is the 3 over 100 multiplied by 196. Right? Or for persons who might think that this is a longer way, we can also multiply the 196 times 0.03. Whichever way you find easier to work with, you can work with it. Right? So for this way, without using the calculator, what you can do is divide 100 into 196, which will give us what? 100 divided by 196 give us what?
1.96.
Right, so looking at the amount of 0 in 196, it would be 1.96. And then to make it easier for us, we can now multiply that by 3 to get our answer. So 1.96 times 3. Everybody say we get 1.96? All right, so the decimal point is behind the 6, and there are 2 zeros in 100, so we move the decimal 2 times to the left, which now give us 1.96 times 3, which then give us 5.88. Everybody see that? As I was saying earlier, if you don't want to do it this way, you could have gone ahead, multiply the 0.03 times the 196, and you would have still gotten the same answer. It's not harder, but it's a bit longer.
Calculator more, it is more.
Everybody see that?
Also to mention that you have to look at what the question asks. Sometimes they ask you how much is the customer pay. So if it asks how much the customer pay, you have to add the cost of the item plus the tax. But this one, yeah, tell us how soon come. But this one is just saying what is the tax. Okay? But sometimes they can ask you how much the customer pay. So what you have to do is add the tax with the what? The 196. Follow?
Yes, sir.
All right.
So you have to read the question carefully.
All right, number 15. He said the cash price of a television set is $350. When bought and hire purchase, a deposit of $35 is required, followed by a 12 monthly payment of $30. How much is saved by paying cash? Now, hire purchase is basically the same thing what you do when you go a court, singer, or one of them Chinese man store. When they go take them things and pay for it over the month.
And
right?
Ms. Lewis, some of these students would have done an SBA like that.
Right.
Right. When they compare quartz and lucky dollar, they have to use that formula.
Right. Now, we all know that for hire purchase, you have to leave some money with the company to put the item on, to basically get the item. So that's what they call the deposit, which is $35. Now, when the company do them work out them hire purchase price, right? Them say you're supposed to pay back $30 every single month for 12 months, right? So to find hire purchase is the deposit plus the amount you're going to be paying back over the 12-month period. But first, the first thing that we need to work is how much we're going to pay back over the 12-month period. How much are we going to be paying back if we're paying $30 for 12 months? $250 plus the deposit. How much is the deposit? I will have to add the deposit to it as well.
$35 plus that will be $295.
So that's $35 plus
$360.
Which give us what?
35 plus 360. equals 395.
395. But what does the question ask us? How much is saved by paying cash? How would we find that?
Minus the cash price.
$45. You'll minus. Oh,
Minus the cash price from the higher purchase price.
Right. So we're going to subtract the cash price from the higher purchase price, which give us what?
45.
$45. So you would have saved $45 if you would have bought it on cash.
Because that's 200.
Let me answer.
Everybody get that?
Yeah.
All right, awesome. So sometimes what I suggest you do if you're reading a question and you don't really know what it's asking for, you can link it to real life situation to try get a better understanding of it. All right, number 18 is a car presently valued at 12,000 depreciate at the rate of 10% per annum. What will be the value of the car 1 year later? How can we find the value of the car 1 year later? If it decreased by 12% and it was currently at $12,000. So if you are them persons that will own a vehicle or you even own a device that you know so once you buy it, you can't sell it back for that amount of money, right? How would you calculate it if it decreased by 10%, depreciate? All right, so somebody in the comment section said we need to find 10% of 12,000. Now, what is 10% of 12,000? 10% of 12,000, yes?
1,200.
1,200. And what would we do with that 1,200 now?
We're gonna minus it from the 12,000.
Minus it from the 12,000 because the car would have depreciated by $1,200. Then we minus it from the 12,000, which give us what?
10,800.
10,800. Everybody get that?
Yeah.
Here's model.
What's the answer? 10,800?
10,800.
All right. So all right, Mrs. is just 19 and 20 here.
All right, sir. All right, so number 19. It said a man basic wage for a 40-hour week is $106. So basically what this is saying is that a man is working, he's doing a particular job. At the end of the 40 week, he might get $106 as in pay. He is paid $5 per hour for overtime. And it's asking if he works 6.5 hours overtime in a certain week, then this wage, then his wage for that week is what, right? They basically asking us what would be his wage for that week. Now, how can we go about finding his wage? What's the first thing that we need to find out?
How much hours they work a week?
Right, them already tell you that already. So for the week, for 40 hours, him work $160, right? But then he go further and he said he's paid $5 for overtime and him work 6.5 hours. So what's the first thing that we need to find? So basically, you know, what this is saying is that you're working on a regular week. So you work for 7 to 3. On a 7 to 3, you work $106 for the week, right? But then you work overtime and you work 6 hours, 6.5 hours overtime, and you're paid $5 for the overtime that you work. So the first thing that you need to find out is how much money you have worked for your overtime. How would you go about calculating that?
All right, what I did, I multiplied the $5 times 5, and then what I got, I multiplied by 5 for the work week. If you work past 5, it will be 40, so multiply by 5.
Well, on the man, I run too fast. All right, listen to this now. You are work, right? Whatever work you do, I don't know. You want to tell me what do you work?
What people? What people?
I'm not hearing. So for example, you're working in a supermarket, right? Your shift is from 8 o'clock to 4 o'clock. And the boss come and ask if you have to work some extra time. During the week, all of the extra time that you work add up to 6.5 hours, right? The agreement is that the overtime where you work, I'm gonna pay you $5 for the overtime. Good? So the first thing you need to find out, you know, say your regular pay $160 when you work at 8 to 4 every week, but you work 6.5 hours extra. So the first thing for you to find your overtime is that you're going to multiply that $5 by the 6.5 hours that you work. And the 6.5, how can we write 6.5 as a decimal? Let's turn it into a decimal. Let's get rid of the fraction so we can work better. What is 6.5 as a decimal? 6.5. So to find out the amount of overtime that you work, you're going to multiply that 6.5 by the $5 that you are promised by the boss. So that are your overtime money.
32.5.
Now, 6.5 times 5 give us what?
32.5.
32.5. Remember now, you get $32.50 with the original pay for the week, right? So what the question is asking us is how much are you going to get in total for just 1 week of work in your original 40 hours plus your overtime?
$192.
So you're gonna do addition.
Right, you're going to add them. So that's 32.50 plus 160, 192.50. Everybody see that?
Yeah, let me just elaborate on the formulas. So basic wage, BW, basic wage is the basic rate. The basic rate is what the company and the employers or whoever, the chairman, whatever, the owners agree to pay you per hour. All right? Multiply by what we call the basic week. So essentially, you know, them actually work out the basic wage for you. Them just say, boy, a man's basic wage for a 40-hour week is 160. So you don't have to work out the basic wage. Then don't tell us it's 160. Well, let me ask you a question. Can I work out the basic rate based on this information here? Can I work out how much money the person earn per hour?
You still can divide the 40 times the 160.
Right, just divide them. That's true. Yeah. Because if I tell us I work $1,000 for every for the week, I work $1,000, and for X amount of hours to work on how much I work for the hour, just divide how much I get for the week by the amount of hours. All right. Now, so you are gonna know overtime. Now, listen carefully. Overtime is when you work outside your contractual your regular contractual working arrangement. All right, you're working extra. All right. Now, whenever you're working extra, usually the company awards the workers more money or a higher pay rate because of various reasons. You know, loss of time spent with family. I mean, you're doing extra work, so you must be tired. You know, so the pay rate, the overtime is usually more, and sometimes they call it overtime factor. Like, for example, a security guard on a weekend will work double time, and probably on a holiday, a public holiday, work triple time. All right, so you might get time and a half during the week, time and a half, the basic rate during the week.
It's time and a half on weekends and two times.
Right, and then something, then it depends on the company or whatever. So basically, to work out your overtime, it's the overtime factor that they agree on, multiplied by the amount of hours you work overtime. Makes sense, huh, Joe? Yeah, man. Makes sense.
Anything over 80 hours of overtime.
All right. Okay, so all right, let's look at let's look at that last one here.
All right. So number 20, it said a salesman sells a car for 10,500. If he is paid a commission of 5% for the first 10,000 and 8% on the remainder, then the total commission received is. So basically, people, car person, even health insurance people, are what I'm calling people that like selling sunset, they people that sells house, right? They normally get
realtor
commission, right? Realtor, right? They normally get commission if they sell a house, a car, or when they make a particular money selling that thing, that item, right? So they said a salesman sells a car for 10,500. And if he's paid a commission of 5% for the first 10,000.
Ms. Lewis, I don't mean to cut you, but even in the BPO sector, when you reach a certain target, you actually get a commission too. Yeah, man. For example, the number of successful customer, the number of successful sales, the number of successful phone transaction. In other words, if there's a complaint and it was handled successfully or it was satisfied, you ever flow ever call it? You ever talk to a flow agent or a digital agent, and when they don't talk to them ask you, what them ask again? So if were you satisfied with your whatever?
Were we helpful?
Right. They're collecting data, and them actually get money when you say yes, I was satisfied. All right. So in time want to give them more money, this time yes. But why? Yeah. So commission goes a long way, man. Trust me, it goes a lot. Whole lot of people get commission. All right.
All right, so how would we go about finding the total commission that this man would receive? What do we need to do? Right.
Work out the percentage of each.
All right. So somebody said find 5% of 10,000, and 5% of 10,000 is what?
500.
500, and then we find 8% of what? 500. Now, you see the 500 that we find the 5% of, that's not what we're going to find 8% of. So do not get that mixed up. What we're finding 8% of is the remainder from the 10,500.
That's the 800.
The 8%?
You're gonna 5% of 8% of 500.
Right. And that 500 is the remainder of the, when we subtract 10,000 from 10,500, that's what we're finding, the 8% of, and not the 500 that we found earlier. So that's
540.
right.
So
So
$40
8% of 500 is 40. We add both of them together, we get 540. Good. Everybody see that?
Yes.
All right, awesome.
All right, let me see if I can manage. Oh, hold on. There is a. So look at that. Tell them to put one cumulative frequency curve in a multiple choice. Class, do you see that?
All right, so remember earlier today when we were looking at the cumulative frequency curve. So here in the, is this a multiple choice, sir?
Yeah.
Right, so we are given a multiple choice question here with a cumulative frequency curve, and they're asking us to find the median. Can somebody tell me how would I find the median of this curve, seeing that there are 200 students in the class? Go back up to the graph, sir. How do I find the median?
Aye. Wanna learn one?
All right, so half of 200, which would be equal to what? 100. So all we have to do is to go across where 100 is. So all we need to do is to
Where is
locate
100 though? Where is 100? I don't see 100.
Between 80 and 120.
All right.
1 centimeter.
But we don't have sense, man. We don't have sense.
Sometimes.
Where we always have sense, but not much sense.
What?
I say just draw a broken line with your ruler, and please ensure that you use your ruler instead of a free hand. And anywhere it touches the graph, you carry it down, and that would be median.
Read it off now. I probably know. Read it off now.
No, all right.
Does the line have to be broken?
Zoom in, sir. Zoom in where the 100 is. Just put the circle where the 100 fall on the graph. Just put a look at that. All right, carry it down. No, just zoom in. Bring up the graph, sir, so we can see the bottom.
No, it go. All right, hold on. I know what to do.
Does it have to be a broken line?
It doesn't have to be a broken line. Once you get it across.
All right, this is the most I can actually All
right, sir, no problem.
This is the most.
Now, between 30 and 40, what does one of those strokes? What does one of those strokes represent?
Between 30 and 40.
Right, one stroke and the graph represent what? Look at it.
About 38, thereabout.
No, man, you have to be very specific.
41.5.
No, man, we don't pass 40, you know.
Yeah, 41, brother.
40. So the line between 30 and 40.
Tell us a rum you put in a coffee, you don't believe me.
35.
So right, the dot line between
48.5.
40 is 35. So simple mean that one of those strokes represent what? 1 mark.
So 37.5.
So would that be between 30, yeah, 37.5. Everybody see 37.5? So I remember it's a multiple choice, so you have to be accurate as
Oh, I
possible.
forgot it was a multiple choice. The answer is
Right.
37.5 then.
You have to be accurate when it's multiple choice.
Let's look at 39 and 40. Well, you notice that it's like it's a similar table what we did this morning, not true, but it's like them do it horizontal. All right, let me say who remember. What is a modal class for this question?
The number that occurs more than once.
All right. So what's the what is a modal class?
40.
40.
It's 40.
Yeah, 40 means 2 times.
Well, so basically 40 is the highest frequency. So the modal class will be 51 to 60, not true? So
Okay.
40 is not the answer, you know. The modal class would be 51 to 60 because these are all what? Classes or class intervals.
So it would be 60.
So right. So remember the 51 would have been the lower limit, and the 60 would be the what?
Higher limit.
The upper limit.
The upper.
Right. If I add 0.5 to the upper limit, what is it called? Wanna play cricket?
A boundary.
All right. We can play cricket, man. Upper class boundary or upper boundary. And if I subtract 0.5 from the lower limit, I'm going to get 50.5. And what is this called now?
Lower class boundary.
Lower class boundary. All right? Yeah, man. So the answer for this, the upper limit of the modal class would have been what? 60. Follow? All right. This is a two-part question. It says, how many children have a mass greater than 40 kilograms?
So you're gonna add from 41 to 70.
The answer D.
Well. So what do you add? What do you add?
The frequency from 41 to 70. So you're gonna add
Very
the
good.
24, 40,
Beautiful.
and 18.
Yeah, man. Iyo wagwan ano. Mama say no. Try answer the question. The question is talking about the weight, the mass of some pitney. All right. So what am I say? 15 of the students then weigh between 21 and 30 kilograms. 35 of them weigh between 31 and 40. So I'm saying, basically what they're saying, the majority of students that took part in the survey weigh between what? 51 and 60. You follow? Yeah, man. So, no for them fat, And look at them slim. You see that? 21 kilogram, a little bit, you know. All right. Right. So how many children have a mass greater? If I say greater than 40, can I start at 40?
No.
I have to start at what? 41. So I start at this 41. All right. So we have 24, and then we have 40, and then we have 18. So what's the sum of 24, 40, and 18?
82.
Very good. Let me ask you a question. If you don't know what you do, and you say multiple choice, if you say I get that right?
No.
You have to know you can't just get up and say, boy, because a multiple choice is easy. If you don't know what you do, you get all them wrong. Tell me that. In a primary school, you can try that. Primary school maths. You can try this something. But you can't try something within a proficiency exam like this. Remember, you know, this exam matriculates you into a degree program, you know. So they want you to think. As a matter of fact, the ministry is cutting out them something, you know. The way they try to say, no, they don't want nobody who left high school to go to college. They want you to do the sixth one. Because what they're saying, the chancellors and the presidents of the university, they don't know nothing when they left grade 11. They're not mature enough, you understand?
Coming to 66. Yeah, he's coming 66.
All right.
Yeah.
Let's look at this one.
Okay. Richard.
What's the answer for this one, please?
Eight.
It's 8. Yeah.
2. Oh.
Oh man, what mode mean? The highest, that's true.
Oh yeah. Okay.
Hold on. You know what some people get wrong? When they think more, they think highest. But the question says, what is a modal score? But you look for the highest value on the student, but it's not the 12 is the answer. It says modal score. So what this is saying that 12 students scored what? 8. So that is the modal score, not the highest score, you know. It's not the highest students or the highest score. It's the highest information that is connected to the information that you want. Get it? And you notice 12 is there also, don't you? I'm gonna know my doing say, oh, modal mean the biggest, so 12 are the biggest number, so put 12. Wrong. It is what is connected to the 12. And this word here, score. Because there's no 12 score up there, not true? There's no score of 12. Follow? So the answer for this would have been what? 8. All right, this one not so bad. 43. This is a very common question. Look at 43.
Let me get 15. Get B, 15.
15? 15 is correct. Very good. All right. So it says, refer to the following bar chart, which shows ages of children who took part in the survey. So it says, how many children took part in the survey? So you know what some people do? Some people say, okay, number of children, and them say 5, and say, oh, 5 are the answer. No. Because this 4-year-old, we have 3 4-year-old, not true? 3 4-year-old, we have 4 what? 5-year-old. So 3 and 4 gives 7. And then plus 2, plus 5 again, and then what? 1. And that will give you what? 15. What is that?
Inspector Mr. Witness.
All right. You guys are tired, don't you? Who there from morning?
Me, sir.
Oh God.
Eh? Who tired, don't you?
No.
All right. What is that? All right, I'm going to have to explain this to you, 46, okay? All right, so I'm going to use what we call a mapping diagram, all right? So, all right, I'm going to use a mapping diagram. So this is X. So we have 2, I'm using this 2 here, 2, -4, and 10. All right, don't pay attention, you know, don't pay attention. And this is the Y, corresponding Y values. So we have 7, 6, and 4. All right, listen carefully now. Now listen. A relation. By the way, what do we call these? What do I call these? Let me see if I a set of points. What's another name for a set of points?
Ordered pairs.
Very good. So listen to this definition. A relation is a set of ordered pairs that obey a particular rule. That's the definition of what a relation is. A relation is a set of ordered pairs that obey a particular rule. All right. Now a function. This is the definition of a function, right? All right. Let me state the definition of what a relation is. A relation is a set of ordered pairs that obey a particular rule. What is a function? Because you didn't talk about relation and function, right? No, a function is a relation. Listen carefully. A function is a relation in which each element in the domain is mapped to one and only one element in the range. Do you get that? Let me say it again. A function, let me tell you what a relation is. A relation is a set of ordered pairs that obey a particular rule. A function is a relation in which each element in the domain is mapped to one and only one element in the range. So in other words, what am I trying to say? All relations are functions. A relation is a function when, let me show you something. You see that? That is a relation, that's true. Sorry. This relation is a function. because it satisfies the definition of what a function is. One and only one element from the domain is mapped to one and only one element in the range. All right? All right. What I know? Look at this now. Suppose I have something like this. Is this relation a function?
Doesn't look like it.
All right. Let me repeat the definition of what a function is. By the way, domain means X values and range means what? Y values, right? So a function is a relation. A function is a relation in which each element in the domain is mapped to one and only one element in the range. Is this relation,
no,
mapping diagram, a function?
No, because 2 and 10 I'm up to 7.
You know, say you're wrong?
Uh,
You're wrong, you know? This relation is actually a function.
Yeah.
The key of the definition, it says each element from the domain. So do we have unique elements from the domain? Yes. We have only one something that come from 2. Only one something that come from what? -4. Only one something that come from what? 10. Let me show you a mapping diagram where the relation is not a function. If you have something like this, do you see that?
Yeah.
Then this relation is not a function because you have 2 things that is coming from the what? The domain. You all follow?
That's all.
All right. All right. Now, having said all of that, what I know? Look at this question. It says the set of ordered pairs below represents a relation that is a function. Which of the following points can you add to this, to the set, that would form a relation that is not a function? In other words, the man want to drop in one. All right, we have 1, 2, 3. So which one of them here would you drop into this that would make the relation not a function? Hey, that question about it, no? Trust me, I first answer a question like this. You have to have some deep understanding of what a relation is and what a function is and what's not a function. Anybody? What point can I add to this series here to make the relation not a function? Currently, it is a function.
Hold on.
Think, man, think. I just talk a while ago. I don't talk, well, still just feel hungry. Anybody?
Sir, A.
Yeah.
Sir.
Come again.
Let's see.
A.
A. Oh my God. Who said A a while ago?
Jody answer.
You are absolutely correct.
Yeah.
Anybody can tell me why, if I add 2, 8?
Oh.
You know what happened? I'm gonna have two. I'm gonna have two. So it's like you have 2. I go to 7, and 2. I go to what? 8. You see that? You all see that? So this is not a what? A function. So anytime you see a mapping diagram where you have 2 arrows that come from the X, it cannot be a function. You get that? All right. Well, not sure. Anybody talking like Tony? Are you there? You following? Miss Planta?
Yes, sir.
You following?
Yeah.
Hold on. John Mark, are you there, sir? All right, let me show you something, class. Let me show you something. Now, we can represent a relation on a mapping diagram, which I just did, and we can represent a relation on a graph. Let me show you something now. Look at this graph, right? Look at the 2 graph here. All right, what's on? Question number 1. Well, I was one question still. Is this graph, let's call it graph A and graph B. Is graph A, is this relation a function? Is this graph a function? Yes or no? How do we know? This is what you do. Draw a vertical line through the diagram. All right? If you draw a vertical diagram, if you draw a vertical line through the diagram, and if the line only cuts the curve at one point or line, then this relation is a what? Function. You get that? If I were to draw a vertical line through this graph here, the vertical line cuts the curve at how many points? 2 points. So guess what? This relation is not a what? A function. Because, for example, it's like you have 2 down here, so you know. It's like 2 is going to 1 point up there, so, and 2 will go what? 1 point down there, so. It's just like the mapping diagram. So this graph here is not a what? A function. You get that? Anybody? Are you guys clear? Are you unclear?
Clear, sir.
Clear as mud?
As what?
As what? As Coolian? Clear as Coolian?
Sir, mud not clear. Water is clear.
Oh, yeah, you can't have clear mud, man. What are you talking?
No.
Enough time I drink water and mud we are drinking, you never know.
There's no such thing as clear mud. Clear mud, not clear mud.
All right. Yeah, I hope you guys get that still. That hope you guys get that. Yeah. All right. Okay. Whoa. I love look at this example. Look at this question here. Hold on.
This is not a function, sir.
Well, yeah. Well, this relation is not a function, but what is it asking is not has nothing to do with whether it's a relation
D.
or a function. What do you think the answer is though? No, it does not. You're correct. You know, the relation is not a function, but it has nothing to do with that. They want you to describe the relation.
I think the answer is C.
Answer is
D.
All right, you are correct.
Which one? D. Okay.
Y is not more than Y no more than X. That's true. As about Y is less than X. That's true. Look at all the Y values. They're all what? Less than X. It says Y is a multiple of X. No go so. Remember, some multiple, you know, keeps on adding. I would say X is a multiple of Y. X is a factor of Y. No go so neither. You follow?
Okay.
Right. So 8 is a multiple of Y. So this has nothing to do with. This has nothing to do with functions and really. This has something to do with computation, multiples. If you realize. All right. Okay. Let's stroll along. Hold on. All right. Let me see who can answer this question. Let me see who are coming to extra class the online class are really. I did something like this on Tuesday or one of them time. I think Thursday. What's the answer for that one?
B.
Can't be wrong, brother. What is a linear function, class? How do you represent a linear function? What's the general format of a linear function?
Y equal M plus C.
Exactly. Y equal mx plus c. So anything with square can't be it. So the obvious answer will be what?
C.
C. Follow? It's just that they just juggle it around. Let me ask a question. If you don't have intimate knowledge about linear function, if you're gonna guess this and guess it right?
No.
Exactly. So you can't just multiple if you don't know what you're doing, you get all of them wrong. First of all, you have to know what is a linear function.
Yeah.
All right, let me ask a question. Maybe some of you may can answer this. What type of function is D? Starts with a Q.
Quadratic.
If you say Q, we get it. It's a quadratic form because all quadratics have this general format: ax squared plus bx plus c. All right. All right. Very good. Very good. Very good. Very good. Very good. You know, I wish I had more students, but you know, it is what it is. I think we did some of these, not true? Let's look at this question here. All right, so 48. Look at 48. It says, what is the gradient? Well, which variable do I call a gradient in y equal mx plus c? Which letter?
Sir, M.
It's M, not true. And I said that x and y are variables and c is the what? The y-intercept. All right. So any number beside x would give us the gradient. So what's the answer?
-3.
You don't say wrong?
Negative 3.
Why is it wrong? Because
So why?
Because this is a y, but what is it?
2y.
2y. So we have to divide everything by what? 2 to get the what? To get the y. So what is the gradient now?
-3/2.
Beautiful. And the intercept would have been 4. All right, so let me just tell you quickly that for tomorrow I'm going to have a class. It is a scheduled class that I have with a group, but I don't know. I need to find out if I'm going to do it online or face to face. I'm not sure, but if I'm going to do it online, I'll let you know, right?
Okay.
Yeah. So if it's online, let me tell you, if it's online, it's from 10 a.m. to 2 p.m. All right, because I do some work with students from Hard Trust. However, I don't know if I'm going to go to the facility. I don't know. But if I'm not going, I'm going to keep it online. And if I'm keeping it online, I'll let you know. So that's some more hours, some more free hours for you guys.
Thank you.
Okay, so let us proceed. We're moving on smoothly. I see a question. I'm going to just jump to this question. And the other night, I think it was Thursday night, right? We yeah, man, we looked at this question. We looked something that's similar like this. It says that a line L is parallel to the line, to this line. So you have two lines. You have that line there, and the name of this line is called what? L. And you have another line, and then the name, well, the equation of that line is what? 2x minus 5y minus 8 equals 0. And the two lines are what?
Equal.
Parallel. All right. Now, when two lines are parallel, it means that the gradient is also what? Equal. So when two lines are parallel, the gradient, they have the same gradient. Remember that? And when two lines are perpendicular, who can remember this? What happens to the gradient when two lines are perpendicular? The product of the gradient equals what? -1. All right. So I sent the recording in the class, so you can watch that. All right. So basically, what am I trying to say? These two lines are parallel, you know. All right, and they give you the equation of this line. So what they do, they want you to find the gradient of L. Now, if we can manipulate this equation and find the gradient, because the gradient is always beside what? X, not true? But guess what the problem is? The problem is it's not in the form of what? Y equals what? Mx plus C. So we need to get it in that format, not true? So we're going to bring over some stuff. So I'm going to bring over the 2x and the 8. So what left back is -5y equal -2x. And that -8 becomes what? +8. You all see that? And then no, it's still not in the form of y. So I'm going to divide both sides by what? -5. So you notice now, these two negatives cancel, not true? So the answer beside x would give us the gradient. So it's actually what? 2 over what? 5. That's the answer. All right. Let's look up. Let's do a little bit of trigonometry. You see, paper done. We have basically covered one exam paper. You notice that? Yeah, almost one. All right, look at 57. It says that's the line y equals x, which I'm sure you're aware of. It says y equals x is rotated anti-clockwise about the origin to 90 degrees. So what is this image? So if we rotate it anti-clockwise is that way, at 90 degrees, we get this. As a matter of fact, we get y equal negative x. That's the name of that line. All right. If I say I rotate it clockwise 90 degrees, you'll still end up at the same place, don't you? Yeah, man. So anti-clockwise or clockwise, we end up with the same value. All right, I think, okay. He said no phone asleep in my class and I'm not tell me. Maybe I talk to myself, I'm a madman.
I'm having some of what you told me to have.
Hey, what's on some minors in the class, you know? You know? Yeah, but then say I'm a big man and big woman from birth, so. Not true. Akira?
She not there.
It's like she going to the supermarket.
Yeah, in a shop.
In a shop.
Yeah, man, I have somebody's spirit, you know?
Okay. Hello? Afternoon.
You belong in my arms, right next to my arms.
Another day of school again. I wish I knew how my day was gonna end. Bye, mommy. Bye, daddy. I got to talk to daddy in the morning.
All right, sorry about that. All right, let's look at 59. 59 is some trigonometry. All right, so as you can see, there's a Z there, not true? An alternative angle, you see that? Alternative angles are equal, not true? So if that's 35, then that must be what?
35.
35. All right. So it's a right angle triangle. All right. So let's label the sides now. By the way, we have a side and an angle, so we use trigonometry. So this side would have been the hypotenuse. Agree?
Yes.
The hypotenuse is always opposite the what? The right angle. And the side that has the reference angle and the right angle is called, which side is that called?
Adjacent angle.
The adjacent, right? And then by deductive reasoning, the other side would have been the what? The opposite side. True. All right. So the question says, we must find YZ. So what do I normally say? Look for what you have
first.
Right. Oh, by the way, so-called Toa. You have to write that first, so-called Toa. All right, so which side do we have? We have A. All right, and which side do we want?
The opposite.
YZ, which is what? Opposite, not true. So which last, the last two letters, which last two letters have O and A in it? I mean, which, you don't matter about. Which of these three formulas have O and A? Tongue. I mean, tongue.
No, Toha.
Yeah, man, a tongue.
All right, sir. You win.
Hey, man, so the other night, you know, whole night I try to get one joke, and nobody no laugh. You know, nobody laugh, start to laugh. When we lock off the recording, and I'm gonna tell everybody for brushing teeth. That time everybody start to laugh. So tan 35. Remember, you know, TOA is a formula. It is actually what? O divided by A. All right. So the opposite would have been what? YZ divided by the what? The adjacent, which is what? 12. And what did I say? When the unknown they are top, you multiply. So therefore, YZ is just 12 tan 35. All right. So it would have been C.
What, sir? Yeah, so are the only answer that we are done.
Yeah. you know, sir. Yeah, you're right. You're correct. Because I mean, once it determines tan, because you know, but what if you have 2 1x tan? It will be a problem, not true? Yeah, man. So this one's a giveaway. I mean, once it determines a way a tan, you can just, you don't have to work, do the rest. All right. All right. So if I'm bringing a shut off now. You guys remember circle theorem?
I think we do something like that one I time.
Young man, which case is this?
Numbers. Number one.
Number one. The angle. I go again. The angle at the center of us. Angle at the center of a circle is twice the angle. No, hold on. Yeah, the angle at the center of a circle is twice the angle standing on the same arc. So if up top is 50, down bottom is what? 100.
Yeah, no number
twice.
one.
All right. Look at 54 easy. You know what's 54?
P equal Q.
Yeah, that's a Z. You see Z? Yeah, man. Equal Q. Hey, you hear me? Yeah, you know, hear me?
Yeah.
I'm just tired, you know.
All right, I'm going to finish drinking local spirit and relax.
All right, students. Thank you so much for, you know, Ms. Coward run gone, but I saw you go still. It's you know, it's a combined class. I'm using some different institutions to run thing. For those of you who have been here with me from morning, I can tell you that, boy, you learned. Let me tell you, if you were able to come to some of the online classes that I would have kept and have absorbed those material, and you should be ready, you know, I'm telling you, you should be ready for the exam. All right, you should be ready for the exam because I would cover a lot of content. All right. As I said before, guys, for tomorrow, I said my boss was calling me a while ago and said not come hard tomorrow. So I don't know. I don't know. So, anyways, thank you for participating and all the best. Okay.
Mr. Steven.
Yeah.
Just want to say, that on behalf of every one of us here, if we, we really appreciate you taking the time out of your busy schedule when you should be resting and spending the time with your family to be here on this particular day.
Right.
Imparting your knowledge.
Right.
And we really appreciate it, and we just want to tell you thanks.
Yeah, man. Respect, man. Respect. And yeah, man. And I know I'm actually volunteering, Yeah.
Yes.
Yeah, I just saw you go still, All right. Yeah, man. I really appreciate it. Yes,
Thank
yeah,
you,
man.
sir.
Yeah, man. Cool. All right. All right. Yeah, I'm gonna try and see if the recording, but I don't know, because I'm not even with the record, I know. Oh, it's recording.